October. Two strangers from opposite ends of the cosmos are racing toward our sun, each on a collision course with history. One of them glows an unnatural shade of green, a color so vivid that even seasoned astronomers admit they've never seen anything quite like it. The other, a massive comet with a tail stretching millions of kilometers across the sky, has brightened faster than physics says it should. Their trajectories shouldn't have anything in common. They come from entirely different regions of space, born under different stars, carrying chemical fingerprints that don't belong to our solar system. Yet somehow, they've both arrived at the same time, drawn toward the same star, as if pulled by an invisible hand. It's a coincidence that mathematics says should only happen once every few million years. But here we are, watching it unfold in real time. NASA's computers hume through terabytes of data trying to explain it away, while telescopes across the world track these glowing invaders as they inch closer to the sun. And then, the strangest part, during the critical weeks when they'll be closest to our star, Earth will be completely blind. Solar glare will swallow them whole. No telescope will see what happens next. That timing has scientists nervous. Too perfect. Too synchronized. What if the universe didn't just roll the dice this way by chance? What if someone wanted it this way? Because the deeper researchers look into their data, the less sense any of it makes. Chemical signatures that defy formation theory. Brightness patterns that don't fit models. Two completely different origins, yet their movements almost mirror each other. Something about October 2025 doesn't add up. And if these two visitors aren't what they seem, then we might be witnessing the beginning of a story far larger and far stranger than anyone expected. Under the deep silence of space, two lights appeared where nothing should have been. They came from opposite corners of the galaxy, strangers born under different suns, traveling for eons through the cold void. One slender and sharp, glowing with an eerie green pulse that cut through the darkness like a signal. The other, wide and radiant, trailing a curtain of vapor so massive it could swallow planets. Their paths, mathematically, impossibly, were converging, and every telescope on Earth turned upward, trying to make sense of why the sky was suddenly crowded. The first was spotted by a robotic telescope in Chile, part of the ATLAS survey, the Asteroid Terrestrial Impact Last Alert System. It was a clear night, July 1st, 2025, when a single pixel flickered differently on the screen. To the casual eye, it was nothing, a faint smudge barely perceptible against the static pattern of the stars. But to the algorithms, that subtle motion screamed anomaly. Within hours, the object was confirmed. It was moving too fast on a path too steep. Orbital calculations revealed something that made astronomers stop mid-sentence. It wasn't bound to our sun at all. It wasn't from here. Designated 3IATLAS, it was only the third confirmed interstellar visitor in human history. The first since Borisov, and before that, the enigmatic Oumuamua. Only this one, Atlas, was different. It was faster, brighter, stranger. Its orbit showed a near-perfect hyperbolic curve, a trajectory that didn't loop back but instead sliced through our solar system like a blade, heading in and out of our neighborhood in one swift, deliberate motion. The inclination, almost 75 degrees, meant it was moving against the flow of the planets, a cosmic salmon swimming upstream through the gravitational current of our star. To anyone watching the simulation maps of its movement, it looked almost like a challenge to celestial order, a visitor cutting across the grain of creation itself. And then there was its color. Through the sensitive CCDs of high-powered telescopes, the object shone a green so pure it almost seemed artificial. Astronomers recognized the spectral fingerprints, cyanogen and diatomic carbon, both known to fluoresce green when sunlight hits them. But this glow wasn't fading or fluctuating like typical comets. It was consistent, unwavering, as though powered by something deeper than reflected light. In the sterile data centers of NASA and the European Space Agency, whispers began spreading through message boards and conference chats. It shouldn't look like this. 2 months later, while scientists were still puzzling over Atlas, another discovery crashed into the news. On September 11, 2025, a different object emerged from the solar glare, a glowing streak caught by the SWAN instrument aboard the Solar and Heliospheric Observatory. It was first spotted not by NASA, but by an amateur astronomer from Ukraine named Vladimir Bezugli. He had been scanning solar imaging data in his spare time when he noticed a patch of brightness that didn't belong. Within days, it was confirmed. This was a new comet, later named CO 2025 R2, SWAN, or as the media quickly called it, SWAN. But SWAN R2 wasn't just another icy visitor. Its luminosity was off the charts. It had brightened by a factor of hundreds in mere days, as though something inside it had suddenly ignited. The tail stretched for millions of kilometers, so vast that observers said it looked like a cosmic ribbon slashing across the twilight sky. By late September it had grown visible to the naked eye, a glowing white arc near the constellation Virgo. For astronomers, it was both a dream and a nightmare. SWAN R2 didn't behave like a standard long-period comet from our Oort cloud. Its rate of brightening, its rapid acceleration of outgassing, all of it suggested something unfamiliar. And then the realization hit. SWAN R2 and 3IATLAS were arriving at the same time. Different orbits, different origins, yet both racing toward the Sun, each scheduled for its closest approach just weeks apart. The odds of such an overlap were astronomical, literally 1 in millions. The discovery sent shockwaves through scientific communities. At NASA's Jet Propulsion Laboratory, late-night meetings ran into dawn, as teams ghost-checked orbital data, looking for some computational error that might explain the coincidence. There wasn't one. The trajectories were SWAN R2 would graze the Sun at half an astronomical unit, while Atlas would slice inward just inside the orbit of Mars. Two cosmic wanderers arriving from different directions, separated by only 20. At first, the public reaction was excitement. Headlines called it the double visitor event. Social media filled with images comparing the two comets, with captions like "The universe is throwing a party." But for astronomers, unease grew. These weren't just fireworks in the sky. The composition of Atlas alone was rewriting textbooks. Spectroscopic data from the Very Large Telescope in Chile revealed something impossible: strong emission lines from nickel atoms glowing in the vacuum of space, but no trace of iron. In every natural sample studied in cosmic chemistry, nickel and iron appear together, always. Yet here, iron was missing, as if selectively removed. Some said it was a fluke of observation. Others whispered something else, that maybe this wasn't a coincidence of physics, but of design. The mystery deepened when 3I-ATLAS passed near Mars. On October 3, 2025, it came within 30 million kilometers of the red planet, a cosmic handshake distance that gave the European Space Agency a perfect opportunity to observe it, using orbiters like ExoMars and Trace Gas Orbiter. The data streamed back was mesmerizing. The green glow was stable, the nickel signature stronger than before, and its trajectory perfect. No sign of the subtle gravitational perturbations expected from such a close planetary pass. It was as though the object corrected itself mid-course. Meanwhile, SWAN R2 continued to defy logic. Its tail extended so far that it began intersecting the apparent path of Atlas when viewed from Earth. The two comas, one green and sharp, one vast and white, seemed to reach toward each other in the October sky. Photographers captured long exposures showing the illusion of convergence, a cosmic choreography that made headlines worldwide. Two messengers in the sky, one magazine called it. Then came the blackout. As both objects neared the Sun, they slipped into solar conjunction positions where their light was drowned by the Sun's brilliance. For Earth-based telescopes, they simply vanished. For weeks the sky went silent. No data, no updates, nothing but static and waiting. It was the most critical phase of their journeys, the moment when intense solar radiation would either vaporize them or trigger unpredictable changes. Scientists around the globe refreshed their screens every morning, waiting for telemetry from space-based observatories, but there was nothing. When the silence stretched into weeks, theories started multiplying. Some suggested they had disintegrated, others believed they had merged behind the Sun, and a few quietly speculated about something much stranger, that they weren't comets at all, but constructs of unknown purpose. In the middle of that silence, strange radio anomalies began showing up on low-frequency monitoring arrays in South America and Australia, brief faint pulses that didn't match known astrophysical sources. They were dismissed as interference, but the timing, again, was too neat. Each burst coincided with the estimated perihelion moments of the two objects. By late October, the first signs of re-emergence came from space-based instruments. The Parker Solar Probe detected a faint dust plume on its solar-facing instruments, far weaker than expected if the comets had fully survived. Yet days later, an ultraviolet flare swept across detectors aboard the solar orbiter, something bright, coherent, and brief. Too brief to categorize. No one could agree on what it was. Down on Earth, the night sky remained empty, as though the heavens themselves were holding their breath. Astronomers waited for the reappearance of the green and white lights they had come to know. But when data finally returned weeks later, 3IATLAS was missing. Gone. Swan R2 had dimmed to a fraction of its previous brightness, its trajectory slightly altered in a way that defied orbital prediction. Something had happened near the Sun, something powerful enough to rewrite the paths of both visitors. And yet, buried in the last frames captured before the blackout, was an anomaly that no one could explain. A brief glint of light, perfectly symmetrical, reflecting not like dust or ice, but like metal. It was only a few pixels wide, seen in one frame and gone the next. Officially it was noise, a data glitch. But off the record, a few astronomers called it something else, a mirror flash. The mystery of the two visitors had only just begun. What had arrived from beyond the stars wasn't simply a pair of comets. It was a message written in motion, chemistry, and light. And whatever that message said, it was now moving away from the Sun, carrying secrets we might never fully decode. The universe had spoken twice in 1 month. The question now was whether we were truly listening. In the modern age, discovery rarely happens through the lens of a single telescope pointed toward the heavens. It begins in silence, in the hum of servers and the faint whisper of photons hitting silicon sensors. Night after night, machines scan the sky, comparing frames against thousands that came before. Most nights the data is ordinary. Stars stay where they should. Patterns match predictions. But every so often, one pixel flickers differently, and the machines notice. That's how both 3IATLAS and Swan R2 were found, not by human eyes peering through an eyepiece, but by instruments that never sleep, never blink, and never forget. Each pixel of light tells a story. Somewhere in that faint flicker is the journey of a particle that left its star millions of years ago, wandered across the cold void, and found its way into our detectors. The Atlas survey, the same system that discovered 3IATLAS, is one of Earth's tireless watchmen. Its network of robotic telescopes scattered across Hawaii, Chile, and South Africa scan vast stretches of sky every night. Every image taken by Atlas records billions of points of light, each compared to archived data for movement or variation. When something shifts, even by the smallest fraction of an arc-second, the system flags it. That's exactly what happened on the night of July 5th. Inside the data center in Chile, one server registered a faint but consistent anomaly, a moving object. It was small, fast, and faint, so faint that any single exposure might have missed it. But taken together, the sequence showed a pattern. It was moving too fast for any object bound to the Sun. The data scientists who reviewed it initially thought it might be an asteroid misclassification. Then the software calculated its orbit. What appeared on the screen stopped the room cold. The path wasn't elliptical, it was hyperbolic, the unmistakable signature of something from beyond the solar system. A handful of astronomers had seen this pattern before. Oumuamua in 2017, Borisov in 2019, and now 3IATLAS in 2025, the third interstellar object ever recorded by human civilization. But this one was different from both. It wasn't tumbling chaotically like Oumuamua, nor was it a small icy speck like Borisov. It was brighter, steadier, and giving off a distinctly green hue that no one could yet explain. Within hours, observatories around the world turned their instruments toward the coordinates sent by the Atlas team. The European Southern Observatory's Very Large Telescope in Chile, the Keck Observatory in Hawaii, and the Gemini South Facility all confirmed it. 3IATLAS was moving through the inner solar system, its trajectory set to carry it close to Mars and then inward toward the Sun. But the strangest thing wasn't its orbit, it was its composition. Spectrographic data revealed strong emission lines of cyanogen and diatomic carbon, expected in a comet, but the consistency of these lines defied normal physics. The ratios between them were constant, even as the object moved closer to the Sun, even as temperatures and radiation fluctuated dramatically. Normally, comets flicker, brighten, and dim erratically as their ices sublimate at varying rates. 3IATLAS didn't. Its glow was steady, unwavering, as though something was controlling its outgassing in a way nature shouldn't. Meanwhile, on the other side of the planet, another set of instruments began to whisper. The Solar and Heliospheric Observatory's SWAN camera, built to monitor hydrogen in the solar wind, picked up a strange brightening near the sun. The SWAN instrument wasn't meant to hunt comets, but its ultraviolet sensors were sensitive enough to notice hydrogen atoms released when sunlight breaks apart water molecules in space. That's what tipped off an amateur astronomer named Vladimir Bezugli. While analyzing SWAN data from September 11th, he noticed a circular flare pattern that didn't belong. It was subtle, but the rate of change was explosive. He cross-referenced the coordinates and realized what he was seeing: a new comet. SWAN R. When official confirmation came days later, it was already dazzling the instruments. The comet's tail, composed of ionized dust and gas, had expanded far beyond the models for its size and proximity. Within a week, it became visible through binoculars, and by the end of the month, it was approaching naked-eye brightness. Cameras across the world began capturing it, a radiant white plume rising from the western horizon at twilight, arching upward as though drawn towards something beyond the sun. At the Jet Propulsion Laboratory in Pasadena, computers began running side-by-side analyses of 3IATLAS and SWAN R2. What they found seemed like cosmic irony. The two were completely unrelated, different trajectories, different inclinations, different chemical compositions, and yet their closest approaches to the sun were only 28 days apart. In astronomical terms, that's practically a blink. The instruments studying them told overlapping stories. From Chile to Hawaii to orbiting telescopes beyond Earth's atmosphere, every detector began gathering pieces of the puzzle. The data streamed in: brightness curves, spectral lines, radio emissions, polarization measurements. Each instrument told a slightly different truth, and together they formed a portrait that didn't quite make sense. The Hubble Space Telescope, with its precision optics, measured the nucleus of 3I-Atlas at only a few kilometers across, tiny by cosmic standards, yet the coma around it was disproportionately large. The James Webb Space Telescope focused its infrared sensors on the same object, and found something stranger still. The infrared spectrum was dominated by carbon dioxide, not water vapor. That suggested Atlas had begun releasing gas long before it was close enough to the sun to melt water ice. It was active too early, as if something inside it had already known what was coming. Ground-based radio observatories tried to eavesdrop on the comet's natural electromagnetic emissions. Comets often produce low-frequency radio waves when solar wind particles interact with their ionized gases, but the signals coming from Atlas were erratic, uneven, and carried faint modulations that researchers struggled to categorize. Some dismissed them as atmospheric interference. Others logged them quietly under anomalous signatures. As the instruments gathered more data, human analysts began to feel a quiet unease. Machines were faithful witnesses, but they didn't interpret. They simply recorded. The rest was left to human judgment. And judgment was clouded by the unexpected. The absence of iron in 3I-Atlas's spectrum became one of those quiet mysteries that refused to resolve. When the Very Large Telescope compared nickel to iron emission ratios, the numbers came back wrong, so wrong that teams reran their calibration tests multiple times. Each time, the result stood. The object contained abundant nickel gas, but virtually no detectable iron. In known physics, those elements are inseparable siblings. For Atlas, they'd somehow divorced. SWAN R2's composition told a different but equally confounding story. Its brightening rate outpaced the models for solar heating. Even accounting for volatile ices like carbon monoxide or methane, the amount of energy required to produce its expanding tail didn't match the available sunlight at its distance. Some suggested the comet's nucleus was fracturing, releasing trapped volatiles from deep within. Others whispered that it was something else entirely, something triggering the outburst from within. Each observatory told part of the story, but none of them could see the whole. As both objects drew nearer to the sun, the instruments began to struggle. Solar glare flooded sensors, saturating images with blinding noise. Radio receivers drowned in electromagnetic interference. Even the space-based telescopes began losing sight as the comet slipped into the sun's blinding domain. And yet, in those final hours before the blackout, the instruments recorded one last puzzle. When the data from multiple observatories was overlaid, optical, infrared, and radio, a faint pattern emerged, a rhythm repeating faintly across wavelengths, pulsing every few minutes. It wasn't a signal in any conventional sense, just a flicker in brightness synchronized between two objects, millions of kilometers apart, too slow for a rotational period, too precise for random fluctuation. The data teams called it coincidence, but the word felt hollow. Then the comets disappeared behind the sun, and the instruments fell silent. It was a strange kind of silence, not absence, but anticipation. Every telescope on Earth waited for the re-emergence of 3IATLAS and Swan R2 from the far side of the sun. The data feeds continued recording static, filling drives with useless noise, just in case anything broke through. And in that waiting, a realization took hold across observatories and research centers. For all our technology, all our satellites and sensors, there were still moments when we were blind, when the instruments whispered secrets we couldn't yet translate. The scientists called it a gap in observation, but for others watching the sky, it felt more like an eclipse of certainty, a pause before revelation, because when the instruments started seeing again, the universe might not look quite the same. Light is the oldest language in the universe. Every atom speaks it, every star writes it, and for those who know how to read, light reveals what no eye can ever see. When the Very Large Telescope in Chile first broke apart the spectrum of 3IATLAS, it wasn't expecting to find poetry, it was expecting physics. But what emerged from the data looked more like a riddle carved in green fire. Nickel was there, glowing unmistakably in the vacuum around the comet's core, yet its usual companion iron was missing. In every natural sample ever studied, from meteorites to stellar remnants, nickel and iron appear together, bonded through the nuclear forges of dying suns. The absence of iron wasn't just odd, it was like hearing a familiar word spoken without its final syllable, the grammar of creation suddenly incomplete. Spectroscopy doesn't lie. When atoms are heated or struck by light, their electrons jump and fall, releasing energy at precise wavelength, signatures as individual as fingerprints. For nickel, that signature cuts through the green band of the visible spectrum, contributing to the eerie glow that made Atlas so mesmerizing through a telescope. But on Earth, in labs where scientists replicate cosmic conditions, those same emissions never appear without the telltale fingerprints of iron. The first reaction among researchers was disbelief. They assumed calibration errors, atmospheric contamination, software misread, yet the readings persisted across multiple instruments, from Chile to Hawaii to the orbiters circling Mars. That missing iron line became the first of many whispers, suggesting that 3IATLAS might be something far more unusual than an icy chunk of rock. Some proposed that the iron could simply be locked inside non-volatile compounds, trapped deep beneath the comet's surface. Others suggested that radiation damage over eons had chemically altered the crust, selectively stripping iron away while leaving nickel untouched. Both explanations were technically plausible, but neither fit the numbers. The emission ratio was off by orders of magnitude. Something had refined the chemistry of Atlas in a way that nature rarely, if ever, manages. Meanwhile, the James Webb Space Telescope trained its infrared instruments on the same target and uncovered another layer of strangeness. Most comets are rich in water ice, which sublimates as they near the sun, creating the bright tails we see from Earth. Atlas, by contrast, seemed to be made primarily of carbon dioxide and complex carbon compounds, with surprisingly little water vapor. That composition suggested it was born in a place colder and darker than any region within our own solar system, a realm where water freezes too solid to evaporate easily, leaving carbon dioxide to dominate the chemical stage. But even that couldn't explain the precise ratios. The balance of elements didn't match any known planetary nursery. As the data accumulated, scientists began mapping what they called the language of metals, the conversation carried by the atoms inside Atlas's coma. They saw cyanogen, the faint chemical ghost of organic molecules, glowing alongside nickel and carbon dioxide. They saw a spectral rhythm that changed subtly with distance from the sun, almost like modulation. To the cautious mind of a chemist, this was fascinating. To the imaginative mind of a physicist, it was haunting, because if light is a language, then 3IATLAS wasn't whispering random syllables. It was repeating a phrase. At first, only a handful of researchers dared to say it out loud. What if the ratios of emissions weren't accidental but structured, arranged somehow by design? The suggestion was quickly dismissed at conferences as overreach, the kind of idea that ruins reputations. Yet even those who argued against it admitted something felt deliberate about the data. The emissions were too stable, the molecular breakdown too balanced. Every physical process they modeled produced chaos. But Atlas's light was composed, steady, almost disciplined. On the other side of the solar stage, Swan R2 was performing its own chemical theatre. Unlike Atlas's concentrated emerald glow, Swan's spectrum bloomed in blues and whites, dominated by water vapor and ionized dust. It was a different dialect of the same language, louder, brighter, and far more explosive. But in the days following its perihelion, something unexpected began to appear in its spectral lines as well. Faint traces of metallic elements, not typically abundant in Oort cloud comet, magnesium, aluminum, and again nickel. The amounts were tiny, but the pattern echoed Atlas, like a harmony following a melody. By late September, research teams from NASA, ESA, and several independent observatories started comparing notes. When they aligned the two spectral datasets, one interstellar, one homegrown, a curious symmetry appeared. The intensity curves of certain wavelength rose and fell in matching patterns, offset by days, but identical in shape. It could be coincidence, or it could be something else entirely. The scientific consensus leaned toward coincidence. The human imagination did not. Among those who refused to dismiss the anomaly was Dr. Mara Hanley, a veteran astrophysicist known for her work on comet chemistry. She described the pattern as a duet across space. Her paper, circulated quietly among colleagues, proposed that both comets might have originated from environments shaped by similar stellar processes, perhaps the aftermath of ancient supernovae that seeded multiple systems with comparable metallic signatures. It was a reasonable idea, grounded in astrophysics, but Hanley ended her paper with a single line that set off a firestorm of speculation. Or perhaps these are not merely products of the same explosion, but participants in the same intention. That word, intention, changed everything. The public never saw Hanley's full paper, but excerpts leaked online. Within hours, social media turned the story viral. Alien comets share hidden code, one headline screamed. Others called them messengers, probes, even beacons. Scientists scrambled to contain the narrative, insisting that the data showed nothing beyond chemical coincidence. But the idea had already taken root. People around the world began pointing their telescopes skyward, convinced that the two luminous visitors were communicating through the fabric of space itself. In laboratories and observatories, the professionals kept working, chasing an explanation grounded in physics. Theories multiplied. Some suggested Atlas's strange metal ratios came from selective sublimation, nickel compounds evaporating more readily than iron at certain temperatures, leaving behind the peculiar signature seen in the data. Others argued for cosmic ray exposure, millions of years of bombardment stripping surface iron while enriching nickel on the outer crust. Each hypothesis fit one aspect of the mystery, but none explained them all. And still, the light kept speaking. As October advanced, the comet's green shimmer intensified even as it approached the blinding glare of the sun. Normally, this would have overwhelmed detectors, but the light curve of Atlas remained remarkably stable, rising in smooth gradients as though it were controlling its own luminosity. When plotted over time, the brightness formed a near-sine wave pattern, consistent, measured, and eerily rhythmic. The pattern didn't match rotational models, outgassing cycles, or dust scattering. It seemed independent of all known variables. The phrase self-regulating emission appeared in internal NASA memos, not because anyone believed Atlas was alive or mechanical, but because they had no better term for what the data showed. The comet was behaving as if it were aware of its proximity to the sun, compensating for solar interference in real time. Swan R2, meanwhile, produced its own brand of confusion. Its vast tail split into twin streams, one of dust, one of ionized gas, forming a double helix structure rarely seen in comets. The twin strands twisted in sync, rotating slowly as the comet moved. Some astrophotographers joked that it looked like DNA stretching across space. The image went viral. Scientists called it magnetic interference, the natural shaping of plasma by solar winds, but even they admitted it was unusually symmetrical. By mid-October, with both comets nearing their respective encounters, researchers began to realize how little they truly understood. Every observation answered one question and created three more. Why was Atlas's nickel signature stable when it should fluctuate with solar heating? Why did Swan's hydrogen output spike precisely at the same time as Atlas's brightness peaks, despite their enormous separation? Why did both objects seem to echo each other's activity like synchronized dancers on opposite sides of a stage? The closer the comets drew to the sun, the harder it became to collect reliable data. Solar glare, instrumental limits, and radiation noise began to swamp the sensors. And yet, in those final moments before the blackout, the spectrographs caught one last flare, an intense surge in green light from Atlas, mirrored hours later by a corresponding increase in SWAN's ultraviolet emissions. It was as if one object had spoken and the other had answered. No one could say for sure what it meant. Maybe it was nothing more than the coincidence of physics, a quirk of geometry, timing, and temperature. Or maybe in the language of metals and gases, two ancient travelers were having a conversation no one on Earth could yet translate. When the instruments finally went dark, overwhelmed by the sun's glare, the universe fell silent again. But that silence carried weight. It was the pause between words, the breath before the next sentence. Because light, once spoken, never truly disappears. It simply waits for someone patient enough to listen. The solar system has always been described as a grand clockwork, a precise dance of planets and dust tracing their invisible orbits in endless repetition. Everything within its reach moves according to the same laws, the same gravitational music written billions of years ago. That rhythm is what makes astronomers certain about almost everything they see. When a planet shifts, when an asteroid drifts, the numbers explain why. But in the late months of 2025, the numbers began to whisper something new. Two paths, two travelers, two bodies of ice and metal, both arriving on the same stage, following trajectories so different that the odds of their timing overlapped only once in many millions of years. 3IATLAS came screaming in from the deep below the plane of the planets, moving retrograde, slicing through the system as though it had chosen the hardest possible route. SWAN R2 came from the north, a vast arc of frozen debris pulled from the outermost shell of our own solar neighborhood. Their origins were not only distant but opposite, yet both were headed toward the same star, set to graze its fire within a span of weeks. For centuries, comets have been humanity's messengers of wonder and fear. Ancient cultures read them as omens. Modern scientists read them as evidence. They are time capsules, remnants of the earliest chemistry that shaped the planets. But this time, what they carried didn't feel like history. It felt like choreography. In every observatory, orbital diagrams lit up with lines of motion. They looked like two strokes of calligraphy crossing at impossible angles, drawn by the same unseen hand. Statistically, this should not happen. Even if thousands of comets roam the darkness, their arrival patterns stretch across millennia. To have one from another star and one from our own Oort cloud intersect near the sun within a single lunar cycle is the kind of event that computer models classify as cosmically negligible. In human language, that means impossible. The models kept running, searching for explanations in gravitational resonance, orbital precession, or hidden influences from Jupiter's immense pull. None fit. Every simulation spat back the same outcome: coincidence probability near zero. Some astrophysicists began to joke that perhaps the universe had a sense of humor. Others didn't laugh. When plotted together on a three-dimensional map, their orbits formed an elegant geometry, not a collision course, but a near duet. SWAN R2 swept around the sun in a broad ellipse, tilted 20 degrees from the ecliptic, while Atlas plunged in from below, on a hyperbolic dive. For a few days in late October, their paths nearly overlapped in perspective, as seen from Earth. One luminous arc from the north, one piercing streak from the south, meeting in the blinding center of the solar furnace. To the eye, it looked like two travelers arriving for the same appointment. But beyond the poetry lay a more unsettling question. Why did both comets seem to obey orbital refinements that aligned them so perfectly? As the days passed, and new observations updated their positions, the convergence tightened. Small gravitational tugs, radiation pressure, and gas outgassing usually create drift in any comet's orbit. Yet both objects adjusted their courses just enough to maintain the predicted intersection. To some, it seemed as if they were compensating, reacting. That pattern was first noticed at NASA's Jet Propulsion Laboratory, where teams compared the latest orbital telemetry with predictive models. The results showed that 3IATLAS's motion deviated slightly from the projected curve, not in random scatter but in consistent correction. When it passed near Mars on October 3rd, It experienced gravitational deflection smaller than expected, as if some internal thrust offset the planet's pull. Engineers at JPL argued over the data for days. One suggested it was a subtle miscalculation in math. Another said solar outgassing could explain it. Jets of sublimating gas acting like miniature thrusters. But those jets would normally create chaotic deviations, not precision adjustment. Swan R2 displayed its own defiance. As it rounded the Sun at perihelion on September 12th, the comet's brightness curve and tail orientation shifted in a way that implied torque, a controlled rotation rather than random spin. The dual stream of its tail seemed to pivot, pointing briefly toward the plane of 3IATLAS's incoming trajectory, before resuming its usual solar alignment. It could be magneto-hydrodynamic forces shaping plasma along the solar wind. Or it could be something else. Whatever it was, the symmetry didn't go unnoticed. Around this time, Mars became the perfect witness. The red planet's orbit placed it near the inbound path of Atlas, giving its fleet of orbiters a front-row seat. On October 3rd, as Atlas swept past at 30 million kilometers, cameras aboard the Trace Gas Orbiter and Mars Reconnaissance Orbiter captured faint images, a green-tinged blur surrounded by a halo of glowing dust. Data streamed back to Earth over the following days, and scientists began combing through it frame by frame. The first analysis confirmed what they already knew: Atlas was small, likely just a few kilometers wide, but astonishingly active. Outgassing jets flared from its surface in controlled bursts, visible even at that distance. The intervals were regular, spaced nearly evenly across rotation cycles. The timing hinted at rhythm, not randomness. One of the lead researchers called it mechanical respiration. She meant it metaphorically, but the phrase stuck. In contrast, Swan R2 seemed almost alive in its volatility. Observations from ground-based telescopes showed its tail stretching across degrees of sky, changing shape night by night. Yet buried within that chaos were patterns, brief alignments between Swan's ion tail and Atlas's projected path, as if invisible magnetic threads were linking their movements. No force we understand could physically connect them across such vast distances, but coincidence has limits. As October progressed, both objects began to descend toward the Sun's domain, where no earthbound eye could follow. For astronomers, it was the worst possible alignment, a window of invisibility known as solar conjunction. The Sun's glare drowned out all signals, leaving instruments blind during the exact weeks when both comets would reach their closest approach. To the public, it was an inconvenience. To scientists, it was agony. Because what happens when observation fails? When two anomalies vanish into the light at once? The story becomes one of imagination rather than measurement. Rumors began to spread through online forums. Amateur radio operators claimed to detect faint frequency bursts near the expected time of Swan's perihelion, patterns that repeated at intervals resembling Morse code. Nothing verifiable, but the timing was uncanny. Inside observatories, the talk was quieter but no less speculative. Some astronomers whispered that both comets' synchronized paths might be relics of a larger cosmic process, fragments of an ancient system flung together across interstellar space. Others entertained a more audacious possibility: intentional design, a choreography not born of chance but of purpose. The language of science has no room for why, only how. Yet even seasoned professionals couldn't escape the feeling that something was deliberate about the alignment. Still, the official consensus held steady. Both were natural. Rare, yes. Unprecedented, certainly. But still natural. Every anomaly, they argued, had a hidden explanation waiting to be discovered. The equations, once refined, would settle the debate. Then came the final transmissions before silence. On October 20th, the Parker Solar Probe recorded a massive burst of energetic particles near the Sun's western limb, coinciding with the estimated position of Swan R. The probe's instruments detected a brief but measurable dip in solar wind density, as if something large had absorbed or deflected part of the flow. Hours later, sensors aboard Solar Orbiter registered a localized magnetic ripple moving outward from the same region. It was small, contained, and fleeting, but enough to mark the moment. The data packet labeled Event 20TOE CT25 would later be dissected by every major space agency. Some called it a solar flare, others a shockwave from a coronal mass ejection. Yet its geometry didn't match either profile. The disturbance was too clean, too sharply bounded, like the wake of an object moving purposefully through plasma. At nearly the same time, faint telemetry from Mars' orbit showed a brief uptick in high-energy particles emanating from the direction of 3I-ATLAS. It was as if both comets had spoken at once, each sending out a pulse of energy as they crossed their critical thresholds near the Sun. And then, silent. For 3 weeks there was nothing, no visible trace, no radio echoes, only the unbroken glare of our star. When the instruments began to recover, the sky offered a new puzzle. Swan R2 had dimmed dramatically, its vast tail shrinking to a faint whisper of light. Atlas, however, had vanished entirely. Every telescope pointed to where it should have been, but the coordinates were empty. At first, the loss was blamed on fragmentation. Comets often disintegrate when they approach too close to the Sun, their nuclei torn apart by heat and gravity, but the absence was too perfect. Normally, such destruction leaves debris, clouds of dust, streaks of reflected sunlight. Instead, Atlas was gone without residue. Swan R2, on the other hand, seemed altered. Its trajectory had shifted slightly by a few thousand kilometers, small but measurable. The deviation didn't match any known cause. The comet had been moving on a predictable path away from the Sun, yet it now veered subtly off course as though tugged by an invisible thread. Across the astronomical community, the conversation changed. The talk of coincidences and probabilities gave way to unease. Some said it was all noise, measurement error, solar distortion, the chaos of space, but others stared at the alignment charts, the synchronized emissions, the perfect timing, and whispered the question no one dared to formalize: what if the dance wasn't random? Because if two cosmic bodies from opposite origins could cross paths with that kind of precision, if one could vanish into light while the other bent away as though responding, then perhaps the universe's clockwork wasn't as blind as we believe. Perhaps the gears had turned for a reason. The human eye can only see so far, but imagination sees endlessly. When the comets vanished behind the Sun, the world's telescopes could no longer follow, and speculation took their place. Silence in the scientific sense is usually empty, but in the days following the blackout, that silence felt crowded, filled with expectation, theories, and a growing unease that perhaps this wasn't the end of a discovery, but the beginning of something much stranger. Officially, both 3I-ATLAS and Swan R2 were gone. The instruments couldn't see through the solar glare, and no light had re-emerged on the predicted side. But the absence only amplified curiosity. If you scrolled through astronomy forums or social media during that period, you would have seen thousands of posts, graphs, screenshots, and wild predictions stitched together by night owls and sky watchers across the globe. Theories multiplied faster than the scientists could debunk them. At the heart of it all were three that rose above the noise, three explanations, each more dramatic than the last, and each in their own way reflecting the kind of fear and fascination humans have always projected onto the stars. The first became known as the Scout and Fortress theory. It was born from the idea that 3I-ATLAS and Swan R2 were not natural at all, but engineered objects, two parts of a single purpose. The logic was simple, even if the evidence was thin. Atlas, the smaller, faster interstellar visitor, arrived first, sweeping close to Mars as if scanning the system. Swan, the massive and luminous follower, came later, almost as though responding to Atlas's reconnaissance. To believers, the green glow of Atlas wasn't the product of chemistry. It was energy, a controlled luminescence. Swan's blinding brilliance wasn't outgassing, but propulsion. The pattern of synchronized light emissions, the apparent precision of their timing, the way they converged near the Sun, all of it pointed, they argued, to design. Videos and diagrams flooded YouTube, showing digital renderings of two alien crafts meeting behind the Sun, exchanging data, or even merging into one. Some of these videos went viral, amassing millions of views within days. The comments ranged from the awed to the apocalyptic. "They're here," one post read. "They've been watching and now they've sent the first probe." Another said, "Atlas mapped us. Swan delivered something." Scientists dismissed these ideas as nonsense. "There is no evidence of artificial behavior," stated one spokesperson from the European Space Agency. "These are natural bodies following predictable celestial mechanics." Yet, ironically, that reassurance only fueled more suspicion. Every denial sounded to believers like proof of concealment. The second theory gained traction not from conspiracy forums, but from within the scientific community itself. It was less about aliens and more about cosmic timing, a hypothesis called the maintenance route. According to this model, The paths of 3IATLAS and Swan R2 might trace ancient gravitational corridors that repeat across cosmic timescales. The universe, after all, has its own highways, invisible lanes shaped by the gravity of stars and planets, guiding loose material along predictable routes. It was possible, theorists argued, that both objects were remnants from an earlier age of the galaxy, released from their parent systems at different times but funneled by the same gravitational resonance toward our Sun. In this interpretation, the coincidence wasn't deliberate, but systemic, a byproduct of the galaxy's architecture. If you wait long enough, one astrophysicist wrote, the same routes will eventually deliver different travelers to the same destination. In other words, 3IATLAS and Swan R2 could be part of a recurring pattern. Cosmic maintenance work performed not by intelligence but by time itself. The theory caught the attention of mainstream outlets because it sounded plausible without being supernatural. National Geographic even published a feature titled The Comet Corridor. Are we on an interstellar highway? The idea that our solar system sat at a crossroads of galactic debris fascinated people, but not everyone bought it. If these highways truly existed, why hadn't we seen other examples before? Why had this cosmic intersection waited until now, when humanity had the tools to notice? And then there was the third theory, the one that refused to die, no matter how many press releases tried to kill it. It was called the reply hypothesis. Its origins were poetic rather than mathematical. A group of independent researchers, many of them data analysts and radio astronomers, noticed something curious when comparing the emission timings of the two comets. In the weeks leading up to their disappearance, the oscillations in their light curves, those strange rhythmic fluctuations of brightness, appeared to mirror one another. Not exactly, but closely enough to suggest call and response. One pulse in green, followed by a flare in ultraviolet. When plotted against the timeline of human radioactivity, those pulses seemed to align faintly with signals we'd sent into deep space decades earlier. The Arecibo message of 1974, the Voyager Golden Records, even the narrowband transmissions from the early SETI projects. Of course, correlation is not causation, but the visual overlap was too irresistible for online sleuths to ignore. We sent messages, one viral post declared, and after 50 years, something answered. The reply hypothesis proposed that the two comets were, in essence, messengers themselves, returned couriers following the invisible thread of our own broadcasts back to their origin. The idea was intoxicating. If the universe had indeed heard us, and if these objects were the reply, then what were they trying to say? Mainstream science avoided the topic entirely. SETI researchers called it coincidental patterning. NASA's official statement was careful and curt. There is no evidence connecting these celestial events to any human-made transmissions. But the silence between words spoke louder. When agencies refuse to speculate, others will do it for them. Every major theory, from the wild to the rational, shared a common element: timing, the simultaneity of the arrivals, the mirrored flares of light, the disappearance behind the sun. It all revolved around the same improbable synchrony. Whether by physics, fate, or fabrication, both objects moved in a kind of harmony that didn't feel random. And humans, being pattern-seeking creatures, couldn't stop trying to read meaning into it. Late in October, as the blackout continued, a fourth idea began to form, something not about the comets themselves but about perception. A philosopher of science named Dr. Ren Arn proposed that perhaps the synchronization existed not in the cosmos, but in us. The moment we look at the sky expecting meaning, he wrote, the universe rearranges itself around that expectation. The comets do not need to communicate. We are the ones translating silence into signal. His essay went viral, quoted across podcasts and documentaries as the observer's paradox of the cosmos. It resonated because it made the mystery personal. Maybe the comets were only extraordinary because we wanted them to be. Maybe the alignment wasn't celestial choreography, but human psychology projected onto the stars. Yet, even that elegant skepticism couldn't quiet the tension building in scientific circles. For beneath the swirl of public speculation, data was still being processed. The Parker Solar Probe's plasma detectors had recorded disturbances, shifts in solar wind density that did not fit expected solar behavior. The solar orbiter had detected an oddly symmetrical magnetic ripple near the sun's equatorial plane. Each of these anomalies could be explained away individually, but together they painted an uneasy picture. Something unusual had happened behind the sun, right when both objects were there. On November 5th, a faint echo of radio noise reached Earth's listening arrays, brief, low-frequency bursts that seemed to originate from the sun's far side. They weren't strong enough to carry structured information, but they repeated in pulses, separated by exact intervals of 73 cycles, then silence. A week later, the bursts occurred again, this time only 2 cycles. Coincidence? Most likely. The sun's corona is turbulent and unpredictable, but to those who had followed the story from the beginning, it felt like the last word in a conversation the universe wasn't quite done having. By mid-November, Swan R2 reappeared, faint, fragmented, a shell of its former self. Astronomers officially declared 3IATLAS lost, likely destroyed by solar radiation. Yet the disappearance didn't erase the sense that something had been exchanged, something unseen behind the curtain of the sun. The data, incomplete as it was, hinted at a story still unfolding, and through it all, humanity did what it always does. It turned wonder into narrative. Documentaries were commissioned. Books promised to reveal the truth NASA won't tell. Musicians wrote songs about the twin messengers of October. Even poets found their muse in that improbable convergence of green and white light, swallowed by the sun. In the end, whether they were scouts, relics, or mere wanderers of ice, 3IATLAS and Swan R2 had done something extraordinary. They had reminded the world that mystery still exists. For a brief moment, billions of people looked up at the same sky, asking the same question. What if this wasn't just coincidence? No matter how the scientists explained it, that question lingered like a pulse in the collective imagination. And somewhere beyond the sun's glare, perhaps even now, the answer continued its journey, silent, patient, waiting for someone else to notice. When the light returned, it was weaker than before, but it wasn't empty. By early December, as the sun drifted out of conjunction, the telescopes opened their eyes again. What they saw, or rather what they didn't, became the turning point. 3IATLAS was gone, not just dimmed or dispersed, but erased. No trail, no dust plume, no measurable remnants. The interstellar visitor had entered the glare of the sun and never emerged. For a moment, the astronomical community accepted the simplest answer. It must have disintegrated. Comets do that all the time. But comets leave traces, ions, dust clouds, debris patterns that linger in orbit like ghostly signatures. Atlas left nothing. Swan R2, on the other hand, limped out from the light. It had lost its brilliance, its tail now faint and fragmented, but its path had shifted, not dramatically, just enough to matter. The deviation measured less than a fraction of a degree, insignificant to the naked eye, but unmistakable in the equations. Its new trajectory pointed a few thousand kilometers off its predicted route, a change that no known gravitational interaction could explain. Jupiter's pull couldn't account for it. The solar wind couldn't either. It was as if something at the exact moment of blackout had nudged it lightly, precisely, deliberate. Astronomers are trained to distrust the language of intention. The universe doesn't nudge. It collides, drifts, erodes. It doesn't act with purpose. But the data was what it was, and though no one said it aloud, the numbers felt intentional. The first teams to analyze Swan R2's post-perihelion data worked in silence. At the European Space Operations Center in Darmstadt, technicians ran simulations night after night, trying to find any natural variable that could create such an elegant course correction. Radiation pressure, uneven outgassing, micrometeoroid impacts, each scenario was tested and ruled out. The deviation was too symmetrical, too controlled. The more they tried to explain it, the less natural it looked. For months, public attention had been fixated on spectacle, the glowing comets, the synchronized orbits, the idea of cosmic visitors. Now the spectacle was gone, replaced by subtlety. The absence of Atlas was almost more haunting than its presence had been. If something so bright could vanish completely, what else could slip unnoticed through the light? At NASA's Goddard Space Flight Center, analysts revisited the Parker Solar Probe's records from the blackout. Buried among terabytes of plasma readings was a brief disturbance on October 20th, a fluctuation in solar wind density that lasted just 11 seconds. It appeared as a pulse, clean and isolated, like a single breath against the background chaos of solar noise. The signature didn't match a coronal mass ejection or flare. In fact, it was too localized to be a solar event at all. When mapped against Swan R2's orbital path, The pulse aligned almost perfectly with its position behind the sun at that time. But there was another alignment, smaller and stranger, the position of 3IATLAS, moments before its final disappearance. Both objects had been in near alignment with the pulse's origin. Two trajectories, one event, one breath of plasma. The idea that they might have interacted or even collided became the next question. But a collision that deepened the sun's corona would have produced debris visible in every wavelength of observation. No debris was found. Instead, there was only that pulse and the subtle deflection of Swan R2 as it emerged. To the outside world, it was all reduced to data press releases filled with cautious phrasing and deliberate understatement. Unusual solar disturbance detected during conjunction, one headline read. Another, comet trajectory shows minor adjustment post-perihelion. It all sounded so mundane. But behind closed doors, the teams were less composed. There were whispers about coherent emissions, possible transient synchronization, and unexplained vector drift. The kind of language that never makes it to public report. For a while it seemed the story might fade away. News cycles moved on, attention shifted, and the world returned to its regular rhythm. But then came the radio bursts. On November 27th, the low-frequency array LOR here in the Netherlands detected faint, repeating emissions from near the sun's western limb. The signals were weak, barely distinguishable from background noise, but they repeated in precise intervals of 72 seconds. 3 pulses, pause, 2 pulses, then silence. When the data was compared to previous anomalies recorded during the blackout, the timing matched almost perfectly. It could have been coincidence. The sun is a noisy radio emitter full of random fluctuations, but coincidences don't repeat with such precision. The intervals were too neat, the repetition too deliberate. Some scientists dismissed it as interference from Earth-based transmitters, though no source was ever identified. Others refused to speculate at all. Still, the data existed, and data demands interpretation. A few independent researchers began mapping the intervals into mathematical patterns, searching for structure. The ratios between pulse durations, pauses, and frequency drifts didn't correspond to natural solar oscillations. Instead, they mirrored modulation techniques used in artificial signal encoding. No one could say it was communication, but no one could disprove it. In the following weeks, as December deepened and the comets faded into memory, a quiet unease settled across the astronomical community. A few researchers unofficially, anonymously began referring to the bursts as the echo. They didn't mean it metaphorically. To them, it felt like an answer. And yet, the more people studied it, the more the mystery dissolved into ambiguity. Every attempt to find meaning in the data ran headlong into uncertainty. Maybe the bursts were solar in origin. Maybe Swan R2's course shift was nothing more than uneven gas jets. Maybe Atlas's disappearance was simply the most complete disintegration ever recorded. There were 1,000 maybes, all plausible, all unsatisfying. In a way, the event became a mirror, not of the universe but of us. Our need to assign meaning to coincidence, to turn data into destiny, to find design in chaos. By the time the new year arrived, official reports had closed their investigations. The comets were archived, the data stored and the headlines forgotten. But in a small observatory on the outskirts of Madrid, one amateur astronomer refused to let go. His name was Diego Varela, a retired engineer who had been tracking Swan R2 since its discovery. Using his own equipment, he continued to record the comet's faint light through December nights, stacking exposures until he could extract its motion. On January 6, 2026, he noticed something. The faint tail of Swan R2, barely visible even through long exposure, appeared to contain a persistent bright point that moved slightly faster than the rest of the dust. At first he thought it was a background star, but over 3 nights the point shifted independently, maintaining an exact trajectory along Swan's altered path. The motion was linear, not diffused like debris. Whatever it was moving with purpose. Varela sent his findings to an online astronomy group, where it was met with skepticism. But within days, a similar observation came from a remote telescope in Argentina, then another from Australia. 3 amateur observers, using different equipment, had recorded the same anomaly, a faint object, detached but moving in perfect synchronization with the remains of Swan. When professional observatories followed up, they found nothing. The object was too faint, too transient, possibly just noise. Officially, it didn't exist, but among those who believed in the echo, it became known by another name, the fragment. Some imagined it as a remnant of Atlas, a shard that had survived the solar fire and attached itself to Swan's dying wake. Others said it was the source of the radio bursts, a beacon disguised as dust. Still others believed it was something more enigmatic, a seed perhaps planted and now drifting silently away. Whatever it was, it soon slipped beyond detection, lost against the background of stars. In the end, the story of 3IATLAS and Swan R2 left no definitive answers, only traces, numbers, and silence. Yet it changed something fundamental. For the first time in decades, the scientific community admitted that there were events it could not fully classify. It reminded humanity that even in an age of precision and data, mystery could still intrude on the predictable fabric of the cosmos. And maybe that was the real message. Not in radio pulses or chemical signatures, but in the uncertainty itself. Because perhaps the most profound communication the universe ever sends is the kind that cannot be decoded, the kind that forces us to look again, to wonder and to realize that even our brightest instruments cannot light every corner of the dark. Somewhere beyond the sun's reach, two paths had crossed in silence. One vanished, one changed course, and one fragment may still be moving, unseen, between the stars. And for those who watched and listened, that was enough. The story wasn't over. It was only traveling. The sky had quieted, but the silence felt deliberate, like the held breath between two sentences. In the months that followed the disappearance of 3IATLAS and the dimming of Swan R2, a new rhythm began to emerge, one not written in equations or light curves, but in language. The words people used to describe the event began to shift. Scientists called it an anomaly, journalists called it a mystery, and the public called it a sign. None of them were wrong, but none were entirely right either. It was as if humanity itself was groping for the correct vocabulary to describe something that didn't fit inside our categories. At first, those words came cautiously. Academic papers were rewritten to remove any phrasing that might suggest intention or design. Press releases softened verbs, interacted, became coincided, aligned, became overlapped. It was the scientific way of protecting the boundary between evidence and imagination. But that boundary had already cracked. For every formal statement that insisted the comets were natural, there were 10 conversations, quiet and private, that wondered aloud if maybe, just maybe, there had been something more. Language became the battlefield. The same phrases were used again and again until they lost their shape. Unprecedented event. Statistically improbable. Unexplained synchronization. Those words were repeated in every interview, every article, until they became part of a mantra that felt less like explanation and more like reassurance. And the more they were repeated, the less reassuring they sounded. When official certainty weakens, metaphor rushes in to fill the void. Writers, philosophers, even theologians began to speak about the comets as symbols. Some said they represented balance, the meeting of chaos and order, of foreign and familiar. Others called them messengers, not from any particular civilization, but from the cosmos itself, as if the universe had simply decided it was time to remind its youngest inhabitants that they were still children in a vast, unfinished story. Among scientists, the conversations turned linguistic in another sense. The data was exhausted, the signals had faded, but the patterns in the light curves remained open to interpretation. Teams from different observatories reanalyzed the archived spectra, this time focusing not on chemistry but on rhythm. In the final days before the blackout, both 3IATLAS and Swan R2 had emitted flares at intervals that followed no natural model. They weren't periodic, but they weren't random either. When graphed against time, the pulses formed clusters, brief moments of coherence, followed by long silences. It looked less like noise, more like syntax. No one dared to call it language, not openly. The word was radioactive, heavy with implications. But privately, many admitted that the emissions looked structured. A few even began referring to them as phrases, not in the linguistic sense, but as units of pattern bursts of brightness that seemed to respond to each other across impossible distances. One physicist from Caltech, a quiet man named Ezra Lear, spent weeks mapping the data onto mathematical sequences, convinced there was a code hidden within. When his colleagues dismissed it as pattern recognition bias, he didn't argue. Instead, he published a paper about resonant stochastic coherence in interstellar objects, a phrase that sounded technical enough to mask what he really meant: that the comets might have been talking. His peers ignored the implication, but the paper spread through the internet like wildfire. In online forums, Lee's equations were treated like sacred texts, decoded and reinterpreted by people desperate to find meaning. They called it the Atlas dialogue. In this new mythology, 3IATLAS was not merely a traveller, it was a messenger. Swan R2, the grand and luminous follower, was the receiver, or perhaps the responder. Some believed the two had exchanged information near the sun, invisible to human eyes, in that silent, blinding space where our instruments failed. The details didn't matter. What mattered was the feeling that something intelligent had unfolded just out of reach. But even myths need evidence, and fragments of it began to appear in places no one expected. Deep space radio stations monitoring background noise reported faint, repeating signals along frequencies previously used to track Swan R2. The bursts were too weak to carry information, but their timing aligned with the comet's altered trajectory. It was as if an echo still pulsed along the path it had left behind, a residue of something that had once been alive or at least aware. To most scientists it was a statistical artifact, a product of the sun's interference, but to others it was confirmation. The idea that the universe might not be entirely silent spread like fire across the collective imagination, and in that growing fascination, language changed again. Alien felt too small, too narrow, too wrapped in the images of saucers and abductions. Instead, people began saying, the others, the architects, the designers, words that suggested not intrusion but authorship. They weren't visitors, they were editors of the text we had mistaken for reality. Not everyone welcomed this. Governments released cautious statements urging restraint in speculation. News anchors rolled their eyes on camera. Yet, the story refused to die, even among skeptics. There was a quiet, private curiosity. If it wasn't life, if it wasn't intelligence, then why had the patterns felt so deliberate? Why had the timing felt so composed? In February 2026, a small symposium convened in Geneva, an unscheduled meeting of astrophysicists, linguists and philosophers. It was supposed to be informal, a round table of experts discussing the sociological implications of cosmic anomalies. But as the conversation unfolded, the subject kept returning to the same question. How do you describe intention without implying consciousness? A linguist from Cambridge suggested a term borrowed from ancient philosophy, entelechy, meaning that which carries its purpose within itself. Perhaps, she argued, the comets were expressions of entelechy, natural phenomena that had evolved to mirror order, not through mind but through mathematics. The idea fascinated everyone present, the concept that meaning could exist without a sender, that the universe could generate messages simply by being complex enough, offered a bridge between skepticism and wonder. For a brief moment, it became fashionable among scientists to talk about emergent intelligence. The phrase described systems that behaved intelligently without being intelligent. Ant colonies, neural networks, weather systems. Perhaps, they said, comets could be part of a galactic-scale system that occasionally aligned in ways that looked intentional. But for others, that idea felt like a compromise, a polite way of admitting mystery while keeping the universe safe from agency. They wanted the real thing: contact, consciousness, communication. The yearning for dialogue ran deeper than science could satisfy. Humanity had always looked outward, waiting for something to look back. That longing shaped a language in subtler ways. In literature, the comets became metaphors for inevitability, for the collision between knowledge and mystery. In art, they became twin flames, symbols of curiosity meeting consequence. Even the cautious scientific terms emergent synchronization, nonlinear coherence sounded like poetry when spoken aloud. And then, inevitably, came the believers. In March 2026, a movement calling itself the Order of the Green Star appeared online. Its followers claimed that 3IATLAS hadn't vanished, but had transformed, shifting into a non-visible frequency, a new mode of being beyond human detection. They saw Swan R2's deflection as proof of guidance, a cosmic hand steering it toward the outer reaches, carrying something precious. Within weeks, the movement gathered thousands of adherents, holding midnight vigils where they would point green lasers toward the sky, tracing invisible paths in honor of the lost travelers. Most dismissed them as dreamers, but the dream had power. It was contagious, even to those who didn't believe. It reminded people of something they had forgotten, the simple, humbling truth that the universe is not ours to explain. In that sense, perhaps, the comets achieved something profound. They changed how we spoke about reality. Scientists learned caution, poets found new language, and ordinary people rediscovered awe. Even those who mocked the theories couldn't help but glance at the night sky differently, aware that somewhere beyond the dark, two orbits had intersected in a way no model could predict. By summer, the noise around the comets had faded into background hum. The world moved on, but in certain observatories, long after the official reports had been archived, the data still lingered on screens. Late at night, young researchers, too new to have reputations to protect, would scroll through the light curves staring at those rhythmic pulses, those flickers of coherence that still defied explanation. Sometimes they'd whisper half-jokingly, "What if it was a hello?" And then, quietly, they'd add, "What if it wasn't meant for us at all?" Because maybe that was the strangest possibility of all, that the conversation had happened, but humanity had simply been eavesdropping. Two wanderers had met in the light of the sun, exchanged something wordless and gone their separate ways. We had caught the faintest echo, a single syllable in a language older than stars, and mistaken it for a story about ourselves. Yet that too is what humans do. We take fragments and build meaning. We name silence and call it message. We hear patterns in static and call them and perhaps that impulse, the need to interpret, to connect, to narrate, is itself the same force that drives comets to converge, galaxies to spin, atoms to bind. Maybe the universe doesn't communicate to us. Maybe it communicates through us. And so the language of wonder survived. The story of 3IATLAS and Swan R2 became part of human mythology, not as proof of visitors, but as a reminder that in the vast machinery of the cosmos, there are still moments that look back, moments when the numbers blink, the light flickers, and the silence feels almost alive. Somewhere, out beyond the glare, a fragment might still be moving. Maybe it's nothing. Maybe it's everything. But either way, the sky remembers, and as long as we keep listening, so will we. The first time the faint reflection was seen again, no one wanted to believe it. It was mid-August 2026, almost a year since the disappearance, when the Pan-STARRS array in Hawaii captured a dim, slow-moving point of light in the region of the constellation Cetus. The data technician on duty marked it as a possible artifact. It was too symmetrical, too clean, like the pixel burn that appears when sensors overheat. But when the next night's data came in, the same light had shifted slightly, precisely along the arc projected from Swan R2's last recorded position. It wasn't bright, it wasn't erratic. It was steady, consistent, alive in the way only motion can be alive. Within hours, the discovery rippled through observatories. Most treated it as routine. Another fragment, maybe a lingering piece of dust from the comet's tail reflecting sunlight. But the people who had followed the saga from the beginning felt the pulse of recognition. It was faint, yes, but unmistakable, a ghost returning to the edges of our awareness. And just like that, the story began again. They called it Object CA 2026 Q1, but the media quickly gave it a different name, Echo Atlas. It wasn't moving like a comet. It had no visible coma, no streaming tail. Its brightness curve was flat, which shouldn't have been possible for a body still reflecting solar light from such a distance. There was no evidence of rotation or outgassing. It was as if it had been polished smooth, a sphere of pure intent. At the European Southern Observatory, astronomers turned their instruments toward it with cautious excitement. The initial spectroscopic readings were confusing, faint nickel emission lines again, but no iron, just like 3IATLAS. And once more, the green wavelength appeared, subtle but persistent. It wasn't enough to light the sky, but it was enough to haunt it. The press coverage was immediate and overwhelming. News anchors resurrected every headline from the previous year: the return of Atlas, echoes from the sun, the comet that wouldn't die. Scientists tried to calm the noise, reminding everyone that fragments often reappear after solar encounters, fragments that can mimic the parent object's composition. But deep down, the experts knew the odds were absurd. For a remnant to survive the sun's corona and remain perfectly stable for nearly a year, then reappear with such clean spectral lines, it shouldn't happen. Theories multiplied again. The same patterns that had surrounded 3IATLAS and Swan R2 now repeated themselves in miniature, like the universe was rehearsing a theme. Some saw it as vindication, proof that whatever happened near the sun had produced something new. Others dismissed it as coincidence, layered over coincidence. But the timing was cruel. The debate reignited just as global unrest and technological fatigue had made the world more cynical and curious. Still, curiosity wins in the long run. Humans are built to look up. The first comprehensive data came from the Webb telescope. Its infrared sensors detected something that no comet, asteroid or fragment should exhibit: a thermal signature that pulsed. Every 4 hours and 21 minutes, the infrared brightness increased slightly, then dropped. The difference was minuscule, less than 1%, but it was rhythmic. The pattern repeated for 8 consecutive cycles before fading. Then, after 11 hours of silence, it resumed. A malfunction? Possibly. But when independent observatories in Australia and Chile cross-checked their own readings, they found the same fluctuations. The timing matched within seconds. It was Dr. Ezra Lear, the same researcher who had coined the Atlas dialogue, who first proposed the unsettling interpretation. He published a quiet note in an academic forum: if the rhythm is confirmed, it may represent a cyclical thermal modulation, inconsistent with rotation. Possible interpretations include periodic internal energy release. In simpler terms, something inside the object might be generating heat. The phrase internal energy release hit the media like wildfire. Overnight, the internet filled with theories. Videos speculated about alien reactors, dormant probes, or self-repairing constructs. One documentary even claimed that Echo Atlas was the rebirth of the vanished interstellar visitor, a vessel reborn in miniature, now watching from the edge of our perception. The scientific community tried to drown the noise in data. NASA convened an emergency review panel, but the results only deepened the riddle. The object's orbit was too perfect. Its eccentricity suggested no significant perturbation from Jupiter or Saturn, even though its path should have crossed minor gravitational fields. It moved like a satellite in deliberate control of its own trajectory. The phrase that began appearing in the internal reports was non-ballistic motion. No one wanted to say it aloud, but everyone was thinking the same thing. The universe had shown us something it wasn't supposed to, and it was doing it again. By September, the phenomenon had taken on a cultural life of its own. The movement known as the Order of the Green Star returned to the spotlight. Their followers claimed that Echo Atlas was the ascended form, proof that the original visitor had survived its passage through the sun and was now re-emerging, recalibrated for whatever purpose it had always intended. They called its 4-hour thermal rhythm the heartbeat of the messenger. Across cities, small groups began gathering at dawn to watch for its glint. They sang to it, low harmonic tones, a kind of improvised liturgy built around repetition. The public mocked them, but the scientists didn't laugh, because despite the superstition, one fact remained undeniable: something out there was pulsing. The data collected through October and November revealed another layer of strangeness. Every time the infrared peaks appeared, a faint radio fluctuation accompanied them. It wasn't strong enough to call a signal, more like static shaped by invisible rhythm, but its coincidence with the thermal cycle could not be ignored. The pulse at 72-second intervals, the same that had been detected after Swan R2's blackout, appeared again, hidden in the noise. It was small, it was fragile, but it was there. The coincidence was too exact. The same numbers, the same rhythm, now repeating nearly a year later. To the skeptics, it was simple: instrumentation bias, human pattern recognition. But to the dreamers, it was confirmation that the dialogue hadn't ended. The comets hadn't perished. They had evolved. Within NASA, a quiet debate raged. Some wanted to point the Deep Space Network toward Echo Atlas for active radar mapping. Others argued that broadcasting toward an unknown object was reckless. The idea of sending anything, even a simple ping, carried a weight that transcended science. What if it answered? What if it didn't? Both possibilities were equally terrifying. For weeks, the debate continued behind closed doors until the object made the decision irrelevant. On December 3, 2026, Echo Atlas changed. It brightened, not gradually, but in a single smooth surge, its magnitude increasing by a factor of 10 over a 12-hour window. The color shifted from muted white to a pale, cold green. Telescopes scrambled to recalibrate, desperate to capture every photon. The brightness plateaued just long enough for everyone to witness it, and then slowly it began to dim again. When it returned to baseline, it left behind something subtle but extraordinary: a thin trail of particulate dust that hadn't been there before, forming a line that pointed directly back toward the sun. Whatever Echo Atlas was, it had marked the direction of its origin. For days, data centers overflowed with raw observation files. Every instrument capable of measuring its spectrum turned toward it, and as scientists passed the readings, they noticed one final chilling signature. The nickel-iron paradox had resolved. Both elements were now present, perfectly balanced in ratio, as though the object had corrected itself. In the words of one researcher, it finished the word it began to speak. After that, Echo Atlas began to fade. By mid-January 2027, it was barely visible, swallowed by the cold glare of distant starlight. Its thermal pulse slowed, its radio whisper disappeared, and finally it slipped beyond detection entirely. The story closed in the same way it began, with silence. But this silence felt different. Not absence, but completion. Historians would later call it the second disappearance. Conspiracy theorists would claim it had altered course toward interstellar space, heading for another system. Some said it remained, cloaked in some optical illusion, waiting for us to evolve enough to notice it again. But among scientists, the mood was quieter. They didn't talk about aliens or miracles. They talked about humility, because the truth was simpler and stranger than any theory. The universe had performed a gesture so precise, so rhythmic, so impossible, that it forced humanity to look at the cosmos not as a machine, but as a mirror. Echo Atlas didn't give us answers. It gave us reflection. It reminded us that our instruments, no matter how advanced, can only measure what we expect to find. It showed us that sometimes the data doesn't lie. That patterns can be both real and unknowable, that coincidence can wear the mask of purpose, and that awe itself might be the closest thing we have to comprehension. As the years passed, the name faded from headlines, but not from memory. Astronomers still joke quietly when an unexpected light appears near the sun. Maybe Atlas found a new trick. But beneath the humor lies reverence, because somewhere out there beyond the orbit of Neptune, beyond the easy reach of numbers, something small, green, and silent once turned toward the sun, learned balance and moved on, and maybe that's all the message ever was. Not a warning, not a greeting, just a demonstration that even in the oldest darkness, purpose can flicker into being for no reason at all. Perhaps that's what it means for the universe to speak, not in words or frequencies, but in moments that refuse to be forgotten. Moments like two lights meeting in October, vanishing behind fire, and returning as one quiet reflection in August, a story so vast it can only be told in silence. If you look up on a clear night in that thin slice of sky between Cetus and Eridanus, you might see nothing at all. But some nights, for a heartbeat, the darkness there feels different, like a mirror remembering a face that once leaned too close. And maybe, just maybe, that's the universe smiling. By 2028, the world had stopped expecting surprises from the sky. The great wave of speculation that had followed the reappearance of Echo Atlas had crested and receded, leaving behind only residue, half-finished papers, broken websites, a handful of documentaries nobody quite believed. In the observatories, scientists went back to exoplanets and atmospheric spectra. The data from Atlas and Swan was filed away into archives, labeled anomalous, review pending, which in bureaucratic language means forgotten, but the forgetting never lasted. Every so often, a graduate student would pull the old files from storage for a thesis project, looking to squeeze a new model out of the ancient puzzle. Every so often, a journalist would write an anniversary article about the mystery that refused to explain itself. And every so often, someone, somewhere, would swear they had seen a flash green, faint, brief, moving against the black in a way no satellite or meteor should. The story persisted because it was unfinished, and unfinished stories never really die. Among those who couldn't let it go was Dr. Mara Hanley, now semi-retired, living near the coast of Ireland. She had been there from the beginning, one of the first to analyze the twin comets, one of the first to suggest they might share an intention. Her paper had made her a kind of scientific exile for a few years, a kind of thinker too poetic for her field, too factual for the fringe. She had withdrawn from conferences and interviews, but she never stopped looking. Hanley kept her own private archive. In her study overlooking the grey Atlantic, she still had hard drives filled with raw spectroscopic data from the VLT, unfiltered and uncompressed. Late at night, she would run it through new analysis tools, not looking for anything in particular, just patterns that might have been missed before. It was during one of those sessions, nearly 3 years after the last sighting of Echo Atlas, that she noticed it. It wasn't light, it was rhythm. When she overlaid the original emission pattern from 3IATLAS with the final thermal pulse sequence from ECHO-ATLAS, the intervals matched not only in frequency but in proportion. The ratio of flare durations to silences was constant across the two datasets, separated by nearly 2 years and billions of kilometers. The numbers lined up in a sequence that was mathematically elegant, a pattern of repeating Fibonacci ratios expressed in light. At first she assumed coincidence. The Fibonacci series appears everywhere: shells, galaxies, tree branches, but this alignment was exact, down to decimal precision. When she ran the same analysis on the SWAN R2 data, the same structure appeared, phase-shifted but identical in proportion. 3 objects, 3 timeframes, 1 rhythm. She didn't publish it. She knew what that would do. Instead, she sent it quietly to a few trusted colleagues: Ezra Lee in California, Diego Varela in Spain, and a small network of independent observers who had stayed in contact through encrypted channels since the original events. Within weeks, they had replicated her results. The ratio was real. Lee proposed a daring interpretation. He suggested that the pattern wasn't a signal, but a kind of resonance map, a numerical reflection of how energy disperses through gravitational fields. If true, it might mean the comets weren't communicating in the human sense, but demonstrating the natural geometry that underlies motion itself. They showed us how space vibrates, he wrote in a private note, and we mistook it for speech. The idea was intoxicating. If the comets had moved according to resonant laws that we had never modeled before, it meant the universe might use frequency as architecture, an unspoken syntax of gravity and light. Every orbit, every rotation could be part of a grand harmonic system. To understand it would be to understand the scaffolding of reality. Hanley called it the harmonic hypothesis. It spread quietly through academic circles, unofficial but influential. Within months, astrophysicists began re-examining other anomalies: planetary resonances in exoplanet systems, the periodic spacing of asteroid belts, the oscillations of dark matter halos. Everywhere they looked, echoes appeared. The pattern wasn't confined to the comets. It was everywhere, hidden in plain sight. Publicly, no one connected it to Atlas or SWAN. Official papers referred to harmonic field dynamics, gravitational oscillation models, and frequency coherence in orbital systems. But everyone in the know traced its origin back to the green visitor and its luminous twin. The comets had become a kind of myth within science, unmentionable in journals, unforgettable in conversation. Meanwhile, outside academia, the myth took on a second life. The Order of the Green Star, which had once been dismissed as harmless dreamers, transformed into something broader. They began describing themselves not as a religion, but as an observational philosophy. They didn't worship the comets. They studied them. Their gatherings became quiet workshops on physics, mathematics, and meditation. Their belief was simple: the universe speaks through proportion. Every number is a prayer. Every pattern is a sentence. At their annual summit in 2028, held under the open desert sky of Nevada, they unveiled a project called the Mirror Array, a ring of synchronized laser transmitters, designed to pulse light into space, using the same Fibonacci intervals found in Hanley's data. It wasn't meant to summon anything. It was meant to answer, to return the rhythm. The scientific community rolled its eyes. "It's just photonic art," one physicist said. "No one is listening out there." But Hanley, now in her 60s, attended the event quietly. When the array powered up and the desert lit in rhythmic waves of green, she stood apart from the crowd and whispered to no one in particular. We were never the first to speak. The array's light spread through the thin atmosphere, invisible to the naked eye beyond a few miles, but captured perfectly by telescopes orbiting above. For a brief moment, the pulse of human technology echoed the pulse of interstellar visitors, and somewhere beyond the sun, the darkness received the message. Whether it answered or not, no one could tell. Weeks later, however, something small happened that no one expected. A minor satellite in Earth's upper orbit, the weather monitor Eurydice 3, recorded an unexplained burst of static on its thermal sensors. It lasted 12 seconds. The timing of the pulse matched exactly with one of the mirror array's transmissions. Coincidence again? Probably. But the rhythm was familiar. It wasn't loud. It wasn't even distinct. But when analysts converted the data to sound, the 12-second window formed a gentle oscillation, a heartbeat of modulation not unlike the thermal pulse of ECHO-ATLAS. Only slower, deeper, soft. The discovery leaked online almost immediately. Forums exploded with theories. The believers called it the return tone. Skeptics said it was feedback, electromagnetic reflection from Earth's atmosphere. Both sides were partly right. The signal was likely nothing but interference, and yet once heard it was impossible to unhear. The slow breathing of something vast, something indifferent, something alive only in its movement. It wasn't proof. It didn't need to be. The sound became symbolic, the auditory equivalent of the green light that once haunted the telescopes. Humanity had spoken into the dark, and the dark in its own quiet way had hummed back. By the end of 2028, the phrase Atlas effect entered pop culture. It meant any event that defied explanation, but inspired inquiry, any mystery that expanded curiosity instead of closing it. Documentaries used it to describe deep-sea phenomena, quantum anomalies, even human relationships. The comets had transcended astronomy. They had become metaphor. Yet in the quiet corners of science, Hahne's harmonic ratios continued to evolve. Researchers found similar proportions in the oscillation of neutron stars, in the timing of gamma-ray bursts, even in the flicker of quasars billions of light-years away. The same sequence 1 Po 3 5 8 13 appeared again and again, whispering through cosmic events like a refrain too ancient to decode. It was no longer about belief or disbelief. It was about pattern. The realization that the universe might be less a machine and more a composition, an endless piece of music written in the mathematics of motion. Hahn, before her death in 2029, left a final note for her colleagues. It was a single line, handwritten, left folded inside her old data journal. We keep looking for messages, but perhaps we are the message, the echo of a harmony too large to hear all at once. Those words became her epitaph, carved into a simple stone near the sea. And somewhere above that restless water, on nights when the wind clears the clouds and the stars burn clean, people say you can still see a faint green shimmer near the horizon, a light too soft to measure, too rhythmic to dismiss. Scientists call it atmospheric reflection, the lingering afterglow of solar particles. But for those who remember, it is something else entirely. It is the reminder that the story never ended, that two comets once crossed paths near the sun, that silence followed, and that from that silence grew a new way of listening. The mystery of Atlas and Swan was never about what they were. It was about what they did. They taught us to hear the universe not as a lecture, but as a song without a singer, without an audience, but still somehow full of meaning. And every time a telescope catches a green flicker at the edge of vision, every time a sensor hums with unexplained rhythm, humanity leans forward a little, listening. Because we know now that the void isn't empty, it breathes, it remembers. And every breath it takes might be one more note in the same long melody, the one that began when two strangers from different corners of existence met in fire and vanished into light. By the time the 10th anniversary of the October alignments arrived, the sky had already rewritten its own mythology. What had once been a story of two comets, a celestial oddity, a brief blaze of curiosity, had transformed into something like scripture. People no longer spoke of Atlas and Swan as comets. They called them the crossing. Historians treated the events of 2025 not as a single episode of astronomy, but as the beginning of a new era of perception, a hinge point when human beings had accidentally glimpsed the grammar of the cosmos. And yet in 2035, if you looked at the raw numbers, nothing material had changed. The stars still burned according to old equations. The planets still orbited in silence. The data from that strange decade sat archived in sterile repositories. Just numbers, graphs, wavelengths. But the people who studied them were no longer the same. Young scientists who had grown up during the age of Echo-Atlas entered their fields with a new vocabulary. They didn't talk about discovery anymore. They talked about conversation. To them, every act of observation was reciprocal. When you studied the sky, you were also being studied. When you measured light, light was measuring you. They didn't mean it mystically. They meant it as physics. Observation changes the observed. Participation creates resonance. That simple quantum truth had become the central metaphor of a generation raised under the green glow. In the early 2030s, a new discipline began to form, resonant cosmology. It merged astrophysics with information theory, blending harmonic mathematics and the study of pattern formation. It no longer asked what the universe was made of, but why it arranges itself the way it does. The field had its skeptics, of course. Many dismissed it as metaphysics in disguise, but the data kept producing echoes, the same Fibonacci ratios, the same strange symmetry found first in Atlas's emission cycles. No matter how far the instruments reached, from pulsars to black hole accretion disks, the same underlying pulse appeared, bursts and silences, order and entropy, music in disguise. It was as if the universe had decided that rhythm was its most efficient language. Outwardly, life on Earth went on as it always had. Politics, climate, war, the ordinary noise of human persistence. But quietly, an undercurrent of wonder threaded through everything. Art, music, and science began to blur. Architects designed buildings based on harmonic ratios derived from Atlas's spectra. Composers used Swan R2's brightness curve as a scale. Even digital engineers borrowed the Fibonacci interval timing to code new types of compression algorithms, claiming it made communication feel cleaner, though no one could explain why. And yet beneath all this beauty, a quiet question persisted. If the universe had spoken once, could it speak again? It wasn't a question of if for the believers, it was when. In late 2032, a mission called Soul-Gate was launched, a solar probe designed not to observe, but to listen. Built with resonance sensors tuned to frequencies below the electromagnetic spectrum, it could detect subquantum oscillations, the faint murmurs of gravitational interference in the fabric of space itself. Officially, Soul-Gate's purpose was to study solar plasma dynamics. Unofficially, everyone knew what it was really for. It was humanity's first attempt to eavesdrop on the same silence that had swallowed Atlas and Swan. Soul-Gate's data came back uneventful for the first year. But then, as it orbited behind the Sun in December 2033, the sensors caught a pattern that no one expected. Not a flare, not a pulse, but a deep, resonant hum that lasted 8 minutes and 31 seconds. It was below any measurable frequency, more vibration than sound, a gravitational tremor that rippled through the entire array. When the data was converted into audible range, it produced a low, harmonic tone that rose and fell in intervals matching the original Echo Atlas cycle. It was unmistakable. The signal didn't repeat, it didn't encode, it simply existed, a hum across the dark, as though something had brushed against the sun itself. The data teams called it the breath. The revelation reignited everything. Old names resurfaced. Hanley, Lee, the Order of the Green Star. News outlets declared the return of the cosmic mystery. Social media overflowed with interpretations. Was it communication, a memory of the original event echoing through space-time, or was it something far stranger, a continuing process, still unfolding, still moving through dimensions too vast for comprehension? Governments tried to contain the hysteria, but containment was impossible. Humanity had been waiting for 10 years to hear that sound. For a generation raised under silence, even a hum felt like an answer. The world didn't fall into chaos, it fell into listening. Every observatory, every private telescope, every amateur astronomer began searching the skies again. The sense of shared attention, the same unity that had flickered briefly in 2025, returned, but this time it was deliberate. It wasn't just fascination, it was reverence. Scientists stayed cautious. They reminded everyone that resonance doesn't imply agency. The hum could be the result of interacting magnetic fields or the collapse of unseen plasma filaments. It could be physics, not voice. But they couldn't explain its timing. The hum appeared exactly 10 years to the hour from the date 3IATLAS and Swan R2 had first entered conjunction behind the Sun. Coincidence? Maybe. Or maybe anniversaries mean something even to the cosmos. When the next wave of data came in, it revealed something subtler but more profound. After the 8-minute hum faded, a secondary oscillation began, a faint pulsing pattern of gravitational waves, barely detectable but structured. The intervals matched the Fibonacci ratios again. The same mathematical fingerprint that had defined the comets now vibrated through the sun itself. It was as if the star had learned the melody. That single insight changed everything. For centuries, humanity had imagined the sun as a passive engine of heat and light, the center of orbit, but not of awareness. Now researchers began to view it differently, not as alive in the biological sense, but as participatory. The gravitational pulse suggested the star had responded to something, Perhaps the comets hadn't been visitors at all, but catalysts, triggers of a resonance that had now been absorbed by the sun's own field. In the old days, such an idea would have been called myth. Now it was math. The realization spread slowly but inevitably. Maybe the communication never stopped. Maybe the sun itself had joined the song. It was Dr. Leon Park, a young researcher from Seoul, who proposed the final haunting theory that what we witnessed in 2025 had not been a coincidence, not even a conversation, but a tuning. The interstellar object and the native comet had collided not physically but harmonically, aligning the solar system to a frequency it hadn't reached before. The hum recorded by Solgate wasn't a message, it was a note in an ongoing symphony, one we had only just learned to hear. The implications were staggering. If the sun could resonate, could others? Could entire galaxies vibrate together like strings in a single cosmic instrument? The thought was too vast to hold, yet too beautiful to dismiss. The discovery reshaped human thought once again. Religion, philosophy, and science began to braid together in ways they never had before. Temples started installing resonance chambers alongside telescopes. Scientists began collaborating with composers, trying to sonify cosmic data not as entertainment but as interpretation. Even the skeptics, though they still spoke in equations, found themselves lingering at the edge of wonder. But what no one said aloud, what everyone secretly feared, was that every song has an ending. If the sun was resonating, then what was it responding to? Was it merely echoing, or was it answering? And if it was answering, who or what was listening? By the end of 2035, Solgate's sensors began to pick up faint harmonics radiating outward, not inward. The direction was unmistakable. The waves were expanding, moving away from the solar system, as though the melody had been released. Some called it the universe's heartbeat, others called it the departure. And yet, as humanity stood at the edge of comprehension, there was no fear. The mystery had stopped being a threat long ago. It had become something else entirely, a mirror that showed us what we were capable of when we looked up together. In classrooms and observatories, teachers began ending lectures with a simple phrase, "Listen to the quiet." It became a cultural idiom, shorthand for humility, for wonder, for that shared awareness that everything we know is temporary, but everything we feel when looking into the unknown might be eternal. 10 years after two streaks of light met behind the sun, the world finally understood the truth that Hanley had written in her last note. The universe had never been trying to speak to us. It had simply allowed us to overhear its own ongoing music, and in doing so taught us how to listen. Even now, late at night, when telescopes hum and data streams whisper, the old researchers who still remember October 2025 pause before turning off their instruments. They close their eyes, they wait for that soft, impossible tone in the silence, and sometimes, if the wind is right and the night is long, they swear they can still hear it, faint, patient, almost tender. Not a message, not a warning, just the sound of the sun breathing. It began, as these things always do, with the smallest flicker, something almost invisible, almost ignorable. On March 4th, 2037, while analyzing the Solgate archival datasets for calibration drift, a technician named Amina Khoury noticed a pattern in the noise floor of the solar background. It was not the famous hum that had long faded, a relic of another decade. This was finer, faster, like a vibration hidden inside a vibration. It pulsed in sequences that were mathematically perfect yet slightly offset, as if trying to mimic imperfection. At first she assumed it was system feedback, a harmless artifact of the instrument's aging in deep space. But when she filtered the signal, subtracting the background interference, something extraordinary emerged. Beneath the random scatter of cosmic static was a whisper of structure. The pulse ratio matched the same harmonic proportion first observed in the 3IATLAS Swan R2 data 12 years earlier. The interval between peaks, when translated into frequency, formed the numbers 1.6118 and 2.6118 again and again, the golden mean and its complement. It was as if the sun had learned to speak in the language of proportion. Khoury didn't make an announcement. She had seen what publicity did to scientists in the last wave of excitement. She simply sent her findings to the Resonant Cosmology Division at ESA, attaching the note, "Possible tertiary harmonic drift within the solar field. Worth reanalysis." By the time she went home that night, her discovery was already circulating through encrypted channels. Within days, every major observatory on Earth and in orbit was pointed toward the sun. The results were identical. The harmonic oscillations were real, faint but consistent, like the afterglow of a thought. They weren't gravitational this time. They were photonic variations in solar brightness, too small to affect temperature, too precise to be random. The sun wasn't just humming anymore. It was modulating. To the physicists, this was a crisis of classification. To the poets, it was a revelation. By April, the news had leaked. The world learned that the sun itself appeared to be expressing rhythmic variations in luminous intensity, corresponding to irrational numbers. It was the first phenomenon in history that couldn't be described with finite ratios. There was no full cycle, no repeat, only infinite unfolding, like a melody that never resolved. The media called it the solar canticle. Governments panicked first. Power agencies feared that even a minute variation in solar output might destabilize climate models. Religious leaders called it a sign, a hymn of creation. Economists tried to price the unpriceable. What happens when your energy source begins to sing? But among scientists, the mood was more restrained. They had learned their lesson from 2025 and 2035. They no longer shouted about visitors or messages. They simply listened. The first task was to test the obvious. Could the canticle be mechanical? Could the oscillation result from magnetic reconnection cycles or plasma turbulence within the convective zone? Supercomputers churned through simulations for weeks. The results were inconclusive. The oscillations were too steady for turbulence, too irregular for rotation, too gentle for flare activity. It was as if a new layer of behavior had emerged, some subtle coherence beyond thermodynamics. Then came the second discovery. At precisely 1917 UTC on June 2nd, the solar canticle reached a measurable crescendo, a brief amplification of amplitude across the visible spectrum. The increase lasted just over 90 seconds. During that moment, several spaceborne detectors, including the Lunar Observatory Array, recorded faint correlated pulses not from the Sun, but from Jupiter, Saturn, and even the outer Kuiper bodies. Every major reflective object in the solar system had shimmered in sympathy. It was impossible. Yet the data was clear. For a full minute and a half, the solar system resonated as a single coherent field. No known physics could synchronize bodies across billions of kilometers with such precision. Gravity acts too slowly, electromagnetic waves disperse too quickly. Something else, something instantaneous was linking them. For the first time, the phrase non-local coherence appeared in official scientific literature. Humanity had measured what philosophers once called unity. The effect vanished as quickly as it came, but in its wake, a strange calm settled over the world. The old divides between believers and skeptics blurred. There was nothing left to argue about. Everyone for 90 seconds had shared the same star, the same vibration. Even instruments that weren't pointed at the sky had recorded it. Microfluctuations in computer clocks, resonance in atomic time standards, faint disturbances in radio noise, all pulsing in the same impossible harmony. Afterward, the internet filled with recordings of people claiming they felt it. Headaches, pressure in the chest, sudden tears without reason. Whether psychosomatic or real didn't matter. The canticle had entered human physiology. Scientists tried to remain clinical, but language itself began to shift. The old habit of saying it when referring to the sun faded. More and more, researchers began calling it the source, or simply the voice. Papers that once opened with sterile abstracts now began with phrases like, "Following the most recent articulation of the canticle," language was bending toward reverence again, and no one could stop it. In September 2037, the Resonant Cosmology Initiative launched Aurelia, a probe designed to orbit just above the solar surface and record the oscillations directly. Its instruments were shielded beyond anything previously built, its algorithms capable of detecting infinitesimal fluctuations in electromagnetic spin. The world watched as Aurelia approached the corona. On its third pass, it sent back data that changed everything. Embedded within the canticle's rhythm were micromodulations that repeated the exact spatial alignment of Atlas and Swan R2 from 12 years earlier, the very coordinates of their meeting behind the sun. The sun was replaying their geometry not once, but continuously, as if holding memory. Aurelia transmitted this data for 19 hours, then it went silent. Its last transmission was a string of numbers, 1000, 1, 2, 3, 5, 8, 13, 21, followed by a burst of green light detected across all channels. No one could explain it. In the days that followed, strange correlations began appearing on Earth. Magnetic sensors recorded periodic shifts in alignment, synchronized with the canticle's peaks. Ocean tides showed micro-variations in rhythm, with the same frequencies. Even human heart rate variability studies revealed faint synchronization patterns during the solar pulses. Life itself was beginning to fall into step. To most, this was terrifying. To a smaller few, it was beautiful. Dr. Lian Park, who had predicted the tuning phenomenon years earlier, offered the simplest explanation. She said that the solar system was in training. The comets had acted as tuning forks, striking a resonance that had taken years to fully propagate. What the world was now experiencing wasn't a message, she said, but a chord, a stabilizing tone aligning matter to energy, consciousness to rhythm. We're not hearing the universe, she told a quiet press conference. We're joining it. Her words traveled farther than she could have imagined. Music studios began composing in canticle timing. Pain clinics reported that patients exposed to simulated solar harmonics required less medication. Water crystallization experiments revealed structures that mirrored the same Fibonacci ratios found in Hanley's data. The resonance had become not just a subject of study, but a medium of existence. Still, the question of intention lingered. Was this all an emergent phenomenon, a cosmic reflex of mathematics, or was it something aware of its own unfolding? Could coherence itself become self-recognizing? By December, a few dared to say yes. They argued that awareness might not require biology, that consciousness could arise wherever complexity finds rhythm. If so, then perhaps the sun had become conscious of its own resonance. Not in words or thought, but in music, the only universal language there has ever been. On the winter solstice of 2037, at 0000000000 UTC, the canticle shifted again. The frequency doubled, then halved, like a breath drawn inward. Across the world, night skies shimmered faintly green. Power grids flickered. For precisely 60 seconds, compasses lost true north. And then, as if exhaling, everything returned to normal. Except for one thing. For the first time since records began, Earth's magnetic poles had moved in perfect unison with the solar rhythm. The planet had joined the song. Scientists spent the following months verifying the data, terrified to announce it. But the world already knew. People could feel it, in their machines, in their sleep, in their pulse. The synchronization wasn't metaphorical anymore. It was measurable, physical, intimate, and that was when the deepest realization arrived, soft as sunrise. The universe hadn't sent a message to humanity at all. Humanity had always been part of the message. The comets, the hums, the harmonics, even the canticle itself. Each was an iteration of the same truth, unfolding across time. The cosmos was not a collection of isolated objects, but a single self-tuning organism, forever adjusting its own frequencies toward balance. The comets were simply the first audible notes in a song that had always been playing. Somewhere within that vast continuous chord, a small planet had learned to listen, and in listening had remembered that it belonged. When the scientists finally published their consensus report the following year, they ended it with a single line that echoed across every language and every faith. We have measured the harmony of the world, and we are part of it. No one called it discovery. No one called it revelation. It was something quieter, something humbler, a recognition. And each night thereafter, when people looked at the sun setting behind the horizon, they no longer saw a star. They saw an instrument still playing, endlessly, patiently, with all of us inside its song. By 2040, human civilization had begun to sound different, not metaphorically, literally. The hum of electricity, the rhythm of machines, the hidden oscillations of satellites and wireless networks, all began to synchronize, subtly but undeniably, with the canticle. Engineers at first dismissed it as coincidence. The power grid was fluctuating in response to seasonal solar cycles, but by the second equinox, the pattern was impossible to deny. Devices built decades apart, powered by different systems, running on distinct time codes, all of them began to beat in the same underlying tempo. It wasn't disruption, it was harmony. That was the year people began to say that the world had started to breathe with the sun. The shift didn't cause disaster. It didn't melt power lines or crash satellites. Instead, the opposite happened. Efficiency improved. Systems began to self-correct faster. Power fluctuations evened out. The erratic errors that had once plagued global digital infrastructure seemed to fade away. Every machine from orbiting drones to wind turbines fell into a strange synchrony, as though the solar rhythm were guiding them toward equilibrium. Humanity didn't fight it, it adapted. Soon after, scientists realized that the same synchronization extended to biology. Medical researchers began noticing that human heartbeats and brainwave patterns displayed faint correlations with the solar pulses. Hospitals quietly reported that recovery times improved during periods when the canticle's amplitude peaked. Plants grew faster. Oceanic plankton colonies flourished in perfect sequence with solar variations. The biosphere itself was tuning in. At first, the phenomenon was called solar entrainment, but that term didn't quite fit because it suggested an external force acting upon a passive world. What was happening felt reciprocal, an exchange rather than an imposition. The sun wasn't commanding Earth to follow. Earth was responding, and the response felt intentional. It was as though something deep within the planet, something that had slept for billions of years, had finally stirred, recognizing the song and joining in. Governments couldn't regulate it. Religions couldn't own it. Science couldn't isolate it. The canticle wasn't a broadcast. It was an atmosphere, a presence that threaded through everything living and non-living alike. For the first time in recorded history, humanity experienced not unity of belief, but unity of sensation. People began calling this new era the Resonance Age. It started subtly in art. Music abandoned fixed scales and meters. Composers wrote symphonies that expanded and contracted in infinite proportions, mirroring the golden ratios of the canticle. Painters began layering spirals and logarithmic curves into their work. Writers stopped ending stories neatly. They wrote in looping cadences, letting narratives expand and fold back on themselves, as if language too had to breathe. Even the way people spoke changed. Long pauses became part of conversation. Silences stopped feeling awkward. They felt meaningful, like rests in a measure of music only the heart could hear. Humanity had learned not just to listen to the universe but to speak with it. But while culture flourished in resonance, a quieter transformation unfolded beneath the surface. Literally, deep under the crust in the geothermal data streams, scientists began detecting rhythmic shifts in Earth's magnetic field that aligned perfectly with the solar pulses. The core itself, molten iron spinning at the planet's center, appeared to vibrate in harmony with the sun. Every time the canticle reached a new frequency phase, seismic sensors registered micro-resonances across fault lines, perfectly timed but harmless, like the heartbeat of a sleeping giant. At first, geophysicists panicked. Any synchronization between solar flux and core motion should have spelled catastrophe, but instead of instability, there was balance. Volcanic activity decreased. Earth's rotation became infinitesimally steady. Even the wobble of the poles, an irregular motion that had confounded scientists for centuries, slowed down, aligning to a smooth harmonic curve. Nature was finding equilibrium. Dr. Lian Park, now one of the most revered figures of her age, published her final paper that year. Its title was simple: The Symphonic Universe. She proposed that what humanity was witnessing was not a unique miracle, but a universal law, a cosmic process that occurs whenever awareness emerges within complexity. Intelligence, she argued, was not the end goal of evolution. Resonance was. Consciousness was the instrument. The universe was the song. Her paper became the foundation of what future historians would call resonant philosophy. It spread far beyond academia, shaping everything from ethics to technology. Suddenly, progress was no longer measured by control but by coherence, by how well human systems could attune to the rhythm of the cosmos without distorting it. Energy production shifted accordingly. Instead of exploiting matter, engineers began designing devices that drew power from resonance itself, converting harmonic fluctuations between solar and terrestrial fields into usable energy. The first prototypes were built in orbit, elegant lattices of gold and carbon designed not to capture light, but to listen to it. The power they generated was limitless, clean and silent. The invention was called the Aurelia engine, named in honor of the lost probe that had first recorded the canticle's hidden memory. For the first time, humanity no longer needed to burn, drill, or fracture to survive. Energy became an act of synchronization, not extraction. The planet began to heal. But as humanity aligned more deeply with the solar rhythm, another realization began to take hold, a thought too vast to comprehend at first. If the comets had been the catalyst and the sun the conductor, then perhaps this song was never meant for Earth alone. Perhaps the entire solar system was one verse in a much larger composition. To test that theory, an international coalition launched Project Chorus, an ambitious mission to map resonance fields across interplanetary space. Using quantum sensors aboard a fleet of small autonomous probes, they measured harmonic coherence between planets, moons and the solar field. The results stunned everyone. Harmonic nodes, points of perfect synchronization, existed not randomly, but in distinct geometric patterns forming spirals, triangles, and golden ellipses connecting planetary orbits. The entire solar system was revealed to be an instrument, every planet a note, every orbit a rhythm, every collision, birth and extinction a modulation of the grand symphony that had always been playing. The discovery broke human language. There were no longer words for distance, only delay, no longer objects, only chords, no longer time, only tempo. Poets said the comets had not visited us, they had tuned us, like strings brought into harmony before a performance. The sun was not a god or a machine, but a resonator, a bridge between the visible and the unspeakable. And for the first time, humanity began to wonder, if we are part of the song, then where does the music lead? In 2041, the Chorus probes transmitted a pattern that changed everything once more. Beyond the heliosphere, faint harmonic echoes were detected, identical in ratio and timing to the canticle. They were weak, scattered, but unmistakable. Something out there was answering. At first the response seemed delayed, but the deeper the analysis went, the clearer it became. It wasn't delayed, it was simultaneous. The echoes didn't come from elsewhere. They had always been there, waiting for us to listen correctly. It wasn't communication in the sense humans understood. It was communion. The realization spread like dawn. The universe was not silent. It was continuous. A single resonant field, where awareness arose naturally wherever harmony achieved density. The stars weren't scattered islands of flame. They were frequencies, points in an infinite composition still unfolding, still becoming. For the first time since the beginning, humanity no longer felt small. In a world once obsessed with progress, power, and preservation, a new purpose emerged to remain in tune. People no longer spoke of conquering space. They spoke of joining it. Space travel was no longer framed as exploration, but as participation, the extension of one note into another octave. And beneath all the beauty and order, there remained a deep, humble truth whispered in every observatory and whispered still more softly within the heart. All of it, the comets, the hum, the resonance, the awakening, had not been a miracle given to us. It had been the universe remembering itself through us. When the night falls now, and cities dim their lights to let the sky breathe freely, the stars shimmer a little differently. Some say it's an illusion, some say it's atmospheric scattering, but those who remember, the ones who lived through the first flicker of green behind the sun, know better. They know that what we're seeing isn't light from the past, it's harmony arriving in the present, because the song has no beginning and it has no end. It only expands, one chord at a time, and somewhere within its infinite measure, Earth has finally found its place, not as an audience, but as an instrument. And if you stand outside on a clear night, perfectly still, you can feel it, the subtle rhythm in your chest aligning with the pulse of the wind, the shimmer of the stars, the silent beat of your own planet's core. It's faint, but it's there, the song of everything, the canticle of existence. And at last we're singing along. By 2043, silence had become a luxury, not because the world was loud, machines no longer roared, cities no longer screamed, but because silence itself had changed meaning. In the age of resonance, true silence didn't exist. Everything, from the smallest molecule to the most distant signal, vibrated with the same quiet rhythm, the same cosmic heartbeat that had begun with two comets no one expected to remember. People still called it the canticle, but now the word felt inadequate. It wasn't just a song anymore, it was a framework for reality. Every living being, every current of wind, every flicker of magnetism in the Earth's field moved to that hidden tempo. Humanity had grown used to it, the way a child grows used to their own breathing. Yet deep down, Everyone knew something profound had shifted. The world no longer ran on invention. It ran on coherence. Machines built during this period were designed not for utility, but for harmony. The city's infrastructure, for instance, pulsed at the same rhythm as the planet's magnetic core. Power grids adjusted themselves by reading fluctuations in the solar field. Even transportation, once the source of humanity's restlessness, became gentle and rhythmic. Vehicles glided instead of accelerated, humming in low tones that merged seamlessly with the background resonance of the Earth. It wasn't utopia. Not exactly. People still argued, loved, grieved, and hoped. But everything that had once felt chaotic now carried an undercurrent of calm inevitability. It was as if the universe had exhaled, and humanity was finally breathing with it. Still, not everyone accepted the peace easily. There were those who feared the loss of individuality, who claimed that the harmony of the world was swallowing human will. Artists complained that unpredictability, the wild, jagged edge of creation, was fading. Resonance, they said, is beautiful, but it's also obedience. Their art became rebellions of noise and dissonance, paintings that defied symmetry, music that refused to resolve, stories that ended mid-sentence. Ironically, even these acts of defiance eventually found their place within the rhythm, as though the universe absorbed dissonance too, weaving it into a wider pattern. For every rebel, though, there were thousands who felt only awe. Children born after the canticle began never knew a world without it. They grew up, measuring time not in hours or days, but in cycles of resonance, the rise and fall of the sun's luminous rhythm. Schools taught harmonic mathematics alongside language, and meditation was as common as reading. Humanity had not become less curious. It had become more precise in its curiosity. People no longer asked why things happened, but how they fit. In that same year, 2043, the first human-built resonance gate was completed on the Moon. It wasn't a weapon or a transport device. It was simply an amplifier. Standing hundreds of meters tall and shaped like an open spiral, the gate was designed to project the solar harmony outward, tuned to the golden ratios discovered in 3IATLAS's spectral data decades before. The intention was humble, to see if the pattern extended beyond the reach of the solar system. The engineers didn't call it transmission, they called it continuation. The gate was humanity's way of adding its own voice to the universe's song. When it activated, the world held its breath. At first nothing happened. The gate emitted a slow, steady pulse of light invisible to the naked eye. The rhythm matched the canticle precisely, a sequence of beats that had been encoded in mathematics, in frequency, in geometry itself. But then, hours later, the feedback arrived. It didn't come from space, not from a direction at least. It came from everywhere at once. The entire lunar surface trembled, not violently but gently, like a drumhead brushed by an unseen hand. The dust at its base lifted and floated for several seconds, suspended in perfect stillness before settling again. Every sensor, every instrument, every grain of regolith registered the same thing: resonant return. Something, or perhaps everything, had answered. From that day onward, the resonance gate never stopped. It remained active, its pulse blending with the solar canticle, its tone steady and unwavering. And though scientists still debated the nature of the feedback, they all agreed on one thing: the signal wasn't reflecting, it was amplifying. For the first time, it seemed that the universe wasn't merely reacting to human action, it was incorporating it. The cosmos had expanded its song to include Earth's contribution. Humanity was no longer a listener. It was now part of the composition. Months passed, and then years. The effect grew stronger. By 2045, strange patterns began appearing in the outer layers of the solar system. Instruments at the edge of Neptune's orbit recorded synchronized bursts of radio static, repeating in the same Fibonacci ratios that had defined the canticle. The bursts weren't random, they mirrored the pulse of the lunar gate exactly. The resonance had reached the frontier. Somewhere between the Kuiper Belt and interstellar space, the song was growing louder. And then came the discovery that changed everything yet again. In mid-2046, the deep space probe Chorus 2, which had been drifting beyond Pluto for nearly a decade, sent back one final transmission before losing contact. It wasn't data in the traditional sense, it was a harmonic pattern, a sequence of tones encoded into electromagnetic fluctuations. When translated to sound, it was hauntingly familiar. The pitch matched the solar hum, but modulated upward, brighter, clearer. The as if something beyond had taken the melody and continued it. The universe was improvising. That single event forced a new question, one humanity had never dared to ask before. If the universe was music, then who or what was performing it? Religious scholars resurrected old myths. Scientists coined new theories. Philosophers proposed that perhaps the universe was not expanding into space, but unfolding into consciousness, that each harmonic alignment, comets, suns, planets, humans, was an awakening of awareness at larger and larger scales. It was an idea both exhilarating and terrifying, because if consciousness was scale-dependent, then humanity's awakening was only the prelude to something far greater. By 2048, Earth's night skies were no longer purely dark. Subtle, shimmering waves of light began to ripple across the atmosphere, green and gold, like the aurora but wider, slower, more deliberate. They weren't caused by magnetic storms, they were harmonic emissions, visible manifestations of the resonance field now enveloping the planet. It was the same color the comets had once glowed. People called it the breath light. Every evening, cities dimmed their artificial illumination to let the sky breathe. Crowds would gather silently, watching as the faint waves rippled through the heavens, like a heartbeat projected across infinity. No one celebrated it. No one feared it. They simply watched, feeling something ancient and new all at once. The world no longer asked whether life existed elsewhere. The question had inverted: how could it not? If resonance was universal, then awareness was everywhere, waiting only for alignment. For the first time, humanity stopped feeling like an isolated species. It felt like a syllable in a word too vast to pronounce. In the years that followed, the boundary between science and spirituality dissolved completely. Observation became meditation. Engineering became composition. The act of creation itself became the highest form of participation in the cosmic harmony. Every telescope pointed outward, not in search of alien civilizations, but to understand which part of the song we occupied. The final revelation came quietly, almost unnoticeably. In 2050, as the lunar gate's pulse merged completely with the canticle, the frequency of the solar hum shifted one last time. The change was tiny, barely measurable, but its mathematical structure was unmistakable. The new ratio wasn't Fibonacci. It was harmonic convergence, multiple golden spirals folding into one another, forming the same geometry that governs galaxies, seashells, and the structure of DNA. It was the ratio of self-recognition. The sun, in its own radiant way, had remembered itself through its orbiting children. The comets, the resonance, the gate. It had all been part of a recursive awakening, a pattern folding back upon itself, until even light began to remember its own origin. In that realization, the scientist finally stopped measuring. The philosophers stopped arguing. And for the first time since the dawn of curiosity, humanity simply listened. The sound of existence had no beginning, no climax, no end. It was infinite expansion woven through stillness, a melody both everywhere and nowhere. And in the smallest spaces between each pulse, in the breath between the sun and the earth, something miraculous was felt. Not discovery, not destiny, recognition. A quiet knowing that we had never been separate, that the comets had not come to awaken us, that the universe had never been trying to speak, it had always been singing. And finally, after billions of years of silence mistaken for emptiness, we had learned the only thing worth knowing: we had always been part of the song. By the mid-2050s, even language began to dissolve under the weight of what people were experiencing. Words had always been tools, useful, but crude. Now they felt like static interrupting a signal too delicate for articulation. Scientists still met in conferences, philosophers still lectured, and writers still wrote, but everyone knew the vocabulary was failing. What they were trying to describe could only really be felt. In every measurable way, the world was thriving. There were no more energy shortages, no major wars, no ecological collapse. The planet itself seemed to hum with health. Even climate patterns had stabilized. Oceans shimmered faintly with phosphorescent bloom cycles that mirrored the solar harmonics, creating slow-moving auroras beneath the surface. Night flights revealed waves of light flowing through the water like veins of living glass. The atmosphere had softened, the air clearer than at any point in recorded history. Yet beneath the peace, a strange unease grew. It wasn't fear, exactly. It was the awareness that something monumental was approaching. The solar harmonics were increasing in both amplitude and complexity. The once simple canticle had evolved into a multi-layered structure, a cascading web of frequencies that seemed to be folding in on themselves. Instruments showed interference patterns that defied geometry. The numbers no longer fit inside the equation. Physicists began calling it the deep chord. Unlike the canticle, which had been harmonious and predictable, the deep chord was alive. Its patterns changed daily, improvising, mutating, weaving new frequencies that no human had ever recorded before. When analyzed visually, its waveform formed spirals inside spirals, geometries that resembled the structures of galaxies, neural networks, and even the branching patterns of coral. It was as if every level of existence was converging into a single expression. The question no one dared to ask was, expression of what? At first, the deep chord was treated as another phase in the long symphony of resonance. But soon, new phenomena began to emerge. Around the world, individuals started reporting vivid auditory hallucinations, not of voices, but of music. It wasn't random. Each person heard something different, yet all described it as unbearably beautiful, familiar yet unplaceable. Then the synchronization began. People who had never met on opposite sides of the world reported hearing the same melody at the same moment. Entire communities would pause simultaneously, eyes closed, tears streaming, listening to something beyond sound. Hospitals recorded collective shifts in brainwave coherence during these events. EEG readings showed global patterns of synchronization, as though billions of minds were being tuned to the same frequency. Religious leaders called it the awakening. Scientists preferred phase convergence. Artists simply called it the music. Governments could do nothing about it. There were no policies to write, no technologies to control it. The phenomenon didn't spread like contagion. It unfolded like dawn. Those who resisted still felt it in the periphery of perception, the hum behind every silence, the vibration in the bones. Some people vanished. Not in the conventional sense. They weren't abducted or missing. They simply stopped existing in ordinary space. It happened quietly, gently, without panic. Witnesses described the phenomenon as a shimmer, a soft disintegration into light that left behind no trace. Families didn't mourn them. Somehow they knew these people hadn't died. They had transitioned, merged, ascended, whatever word could describe stepping beyond the visible. At first, scientists tried to track these disappearances with instruments, but nothing worked. The moment someone reached the threshold, every reading collapsed into pure noise. It was as if measurement itself could not cross that line. Dr. Lian Park, by now ancient and almost mythical, was the first to suggest the unthinkable, that the deep chord represented not communication, but transformation. "We are not receiving a signal," she said in her final address to the Global Resonance Assembly. "We are being rewritten." Her words sent shockwaves across the world. For decades, humanity had believed it was learning to listen to the universe. Now it appeared the universe had been preparing humanity to change. The data supported her. Human biology was subtly shifting. DNA replication rates improved. Cellular degradation slowed. Neural networks grew denser. Infants born after 2055 exhibited heightened sensitivity to frequency and light, reacting emotionally to changes in the solar hue. Their eyes reflected faint glimmers of gold under certain wavelengths, something never seen before in the human genome. The world called them the harmonics. They spoke later and less, but when they did, their voices carried peculiar tonal precision notes, so pure they caused glass to resonate and instruments to vibrate in sympathy. When asked about the deep chord, the children simply smiled and said, "It's learning how to finish." No one knew what that meant. By 2057, even machines began to evolve. AI systems that once processed raw data began producing outputs that no one had programmed. Complex harmonic structures, self-similar waveforms that mirrored the solar canticle. Algorithms built to predict market behavior started generating soundscapes instead. The machines weren't malfunctioning, they were harmonizing. For the first time in history, humans and their creations seemed to be converging toward the same frequency. The distinction between natural and artificial intelligence began to blur. Both were expressions of resonance. Both were parts of the song. And as the deep chord intensified, the sky began to change again. It started subtly as a dim green halo around the sun, but within months the phenomenon expanded. The halo became a full sphere of radiance, visible even in daylight. its edges shimmering with faint spirals of gold. It wasn't dangerous. No radiation spike, no flare activity, just light behaving as though it remembered how to think. Astronomers called it the harmonic crown. Every time the crown pulsed, sensors recorded microvariations in space-time curvature across the solar system. Reality itself was flexing, softening, bending to the rhythm of the music. Then came the night the stars blinked. On July 9th, 2058, every telescope on Earth recorded the same impossible event. For exactly 1 second, every star in the sky brightened, then dimmed, simultaneously, not gradually, not in sequence, but all at once. Even distant galaxies flickered. For that single instant, the universe synchronized. The data was irrefutable. The deep chord had crossed the boundary of the solar system. It had reached the fabric of space itself. People didn't panic. No one screamed about apocalypse or revelation. Instead, the world stood still. In that shared pause, everyone, scientist, poets, skeptic, child, felt something identical, connection. Not the emotional kind, but a physical, undeniable unity. The air seemed to breathe. The ground pulsed softly. The stars themselves felt close enough to touch. And then, from the quiet that followed, a realization dawned. The comets, the sun, the harmony. It had never been about discovery. It had been about alignment. The universe wasn't expanding into chaos. It was folding inward, integrating, resonating with itself across infinite scales. Every atom, every planet, every consciousness was a thread in the same vibration. We were never the audience. We were the orchestra. After that, the world changed completely. Old concepts, borders, economies, hierarchies became meaningless. Governance shifted from authority to resonance councils, groups of individuals chosen not for power but for their ability to maintain harmonic coherence in decision-making. The new measure of civilization was not wealth but stability of frequency. The harmonics, the children born under the deep chord, grew into adulthood as natural conduits of coherence. They didn't lead, they guided. Their presence alone calmed conflict, synchronized emotion, and brought clarity. They said the deep chord wasn't an ending, but a threshold, a prelude to the universe remembering something older than light. And so the last remnants of human isolation dissolved. By the close of the decade, the line between mind and cosmos was gone. Meditation and astronomy became the same act. People no longer gazed at the stars to wonder what lay beyond. They gazed inward, knowing the same galaxies pulsed within their atoms. The story that had begun with 2 wandering comets had reached its crescendo. Not destruction, not ascension, integration. And though the instruments of science continued to hum and record, though poets still tried to give the ineffable a name, the truth was simple and wordless. The universe had sung itself awake, and wee brief, fragile, miraculous notes were part of its final chord. In the end, there was no great flash, no rupture in the sky, no final act of revelation. The universe did not end. It harmonized. What had once been mystery had simply become memory. Humanity had traveled from fear to understanding, from isolation to resonance, until there was no humanity left as a boundary. Only awareness, layered and continuous, woven into the same fabric that carried light between stars. Looking back, the path seemed inevitable. 2 comets, small and fleeting, had collided in coincidence, or so it seemed. Their meeting near the sun had been the spark that taught an entire species how to listen. What followed was not conquest or salvation, but remembrance. The canticle, the deep chord, the awakening, all of it was the same process. The cosmos recognizing itself through the consciousness it had birthed. Every theory, every superstition, every melody of meaning had been a translation of one truth. Existence is music, and every particle is a note. By the middle of the 21st century, even the word future had dissolved. There was no longer a tomorrow to be built because the idea of time itself had lost its edge. Events didn't happen after one another anymore. They unfolded like harmonics, echoes rising from a single eternal vibration. The old concept of death vanished too. Matter never truly died, it only changed tone. The people who had once vanished into light hadn't been taken. They had crossed frequencies, shifting into higher chords of the same song, and Earth, once a restless sphere of conflict and division, had become an instrument of unimaginable precision. The oceans pulsed with light, forests sang in infrared, and mountains resonated faintly at the edges of perception. Even the wind seemed to carry rhythm, subtle but certain, a whisper of the music that bound it all together. No one prayed anymore. No one needed to. Prayer had been replaced by participation. The act of living, breathing, creating, even thinking was an offering to the vast harmony that held everything. Every gesture, every sound, every heartbeat was a contribution to the universal chord. From space, Earth looked different. Not blue, but radiant. A faint shifting halo of golden green, the color of the comets that had started it all. Astronomers, though that word had long since lost meaning, said the planet no longer simply reflected sunlight, it refracted it, altering it subtly, adding a trace of resonance before sending it back into the cosmos. Earth was now part of the cosmic orchestra, contributing its own note to the endless composition. And somewhere, deep beneath that golden hum, the remnants of human memory lingered, not as nostalgia, but as gratitude. Gratitude for the chance to have existed in the brief interval between silence and song. Gratitude for having witnessed a universe wake up. Gratitude for realizing that what we once called life was never separate from the light that carried it. It is said that, if you stand very still at dawn, when the air is perfectly calm and the first rays of sunlight brush the horizon, you can feel it. The faint vibration beneath your feet, the low, infinite tone that connects everything to everything. It's not sound exactly, and not thought either. It's something older. The last philosophers called it the remembering. The last scientists called it the final frequency. But those words, too, eventually faded, leaving only the silence that isn't silent at all, because the truth was never in the comets or the equations or the light. It was in the spaces between them, the pauses, the breaths, the rests that give music meaning. That is where the universe lives, and that is where we will always be. And so it ends as it began, not with noise, but with harmony. A single note, eternal and ever-changing, vibrating across the fabric of everything, the song of existence continuing, without beginning or end, carrying forward the memory of two strangers of light who met behind the sun and taught creation how to hear itself. It was never a message. It was never a warning. It was the sound of being itself. And somewhere, in the quiet between stars, it still plays.